So good morning all. So on behalf of all the E and ICT academies at IIT Guwahati, NIT Patna, MNIT Jaipur, IIT Roorkee and IITDM Jabalpur, we welcome you all in this third day of 2 weeks online faculty development program on Internet of Things and Applications in Smart Systems. So today we will have lecture number 4, which will be conducted by Professor Manas Khatua sir. Before we start, we will have a short introduction about our next speaker. Dr. Manas Khatua sir is working as an assistant professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Guwahati, India, since May 2018. Prior to that, he was an assistant professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Jodhpur, from 2016 to 2018 and was a postdoctoral research fellow at Singapore University of Technology and Design, Singapore, from 2015 to 2016. He completed his PhD in wireless networks from Indian Institute of Technology, Kharagpur, India, in 2016. He was associated with Tata Consultancy Services India for 2.5 years and worked as lecturer in Bankura Unnayani Institute of Engineering, India, for more than 2 years. His research interests include performance evaluation of communication protocols, Internet of Things, IoT, wireless sensors, sensor networks, network security, cloud and edge computing, and cyber physical systems. He is an author of many reputed international journal and conference publication. He is a member of IEEE and ACM. So with this, we welcome you, sir, in this platform and request you to please uh, conduct the next lecture, number 4, which is IoT Protocols, Data and Network. Over to you, sir.
Thank you. Thank you all. And thank you to the organizer. I hope I am audible and the PPT is also visible, right?
Yes, sir, you're audible also and PPTs are also visible.
Okay. Once again, very good morning to all the participants who are participating online. So today I am going to discuss about the IoT protocols, data protocols and network protocols. So this is as a lecture series for this FDP on IoT and applications, specifically the smart systems on IoT. So in this, I will try to cover the traditional IoT protocols, which are open source, which anybody can use, which anybody can see the code inside. Yes, there are many other protocols also. Just I will briefly introduce them, but I will not go into the detail of those. Specifically, few open source and few are proprietary. So proprietary things are not available. Only the application parts are available. We cannot go into the protocol design, protocol codes. So that's why I will just discuss about one open source, open standard IoT protocol stack related to the data protocols and the network protocols. Okay, so let me start with the very basic. This is the content of today's presentation. I will tell initially the access technologies, then the data protocols and network protocols, which basically design the smart IoT applications. I hope in last few sessions, you have already got the idea about the IoT. What is IoT? Once again, I will just briefly introduce, which will help me to go into the details. So IoT is nothing but a network of physical objects. We know those objects, those physical objects could be any device, any vehicle, any building, any wearables, or any factory, automated systems, whatever it is, or any household equipments. So those devices are embedded with few other things, except the things which are there from the from starting from the manufacturing. So few other things are sensors. They are equipped with communication unit. They will have some processing and computation capacity. So if we have those additional things in the objects, in those physical objects, then we can form a network of those physical objects. That network is the IoT. So that's why the basic goal of the IoT is to connect the unconnected things which are not designed, which are not manufactured at the beginning, keeping in mind that they once upon a time they will be able to connect with the internet. So that was not the initial idea when they were manufactured or when they were designed in the company, by the company. So what it gives basically, using this idea, we can have the smart system. One example I have mentioned here, that smart parking system. So in this smart parking system, we can see that traditional parking system is there, but traditional parking system has many disadvantages. So therefore, people are using this smart parking system using the IoT. I will come to the details of this, how this is working, not with respect to the parking system, but in general, how this IoT works. But just we have to understand that IoT helps us to design the smart parking system by which the driver, before coming into the parking lot, the driver can know that whether any parking position is free or not. If at all it is a free, then in which position this lot is free. So they don't need to find manually that okay, I have to go there, or there is a parking lot open or not. I have to check manually. They don't need to know all these things manually. Automatically, it will be informed to the driver, and accordingly, the driver can plan its trip. Similarly, we know that smart system could be the irrigation system, smart irrigation system. So again, irrigation, the traditional irrigation system is also there, but we know the disadvantages of traditional irrigation system. The farmer need to check manually whether we need to give the water to the field or not. And also, sometimes this analysis, the manual understanding could be the wrong, or sometimes the farmer doesn't know the prediction whether there is going to be rain by evening or whether there is going to be rain tomorrow or not. They don't know this prediction. So if we use this IoT smart irrigation system, then this prediction also involved in the system. So IoT system will inform the farmer that okay, today there is a possibility of heavy rain afternoon, so no need to give the water at this moment. Or how much moisture is there in the field, so that we have to decide the quantity of the water which need to give in this field at this moment. So this is the smart irrigation system we can design using this IoT. Another smart irrigation system, another smart system is the video monitoring and surveillance, which we are very much familiar. Means many vehicles are moving through the road. Thus, this system, automated system, could capture the maybe the count, number of vehicles moving at this moment, the speed, or the if any vehicle is crossing the speed, then automatically it will capture the vehicle registration number, and that number will be informed to the cop, to the police, who to take the further action, because maybe the vehicle has exceeded the speed limit. which is allowed at that point of time in that road. So this type of video monitoring and surveillance can be designed using this IoT based system. Now the basic thing is how this IoT based system works. If we try to understand from the very high level how it works, then we can visualize the whole working functionality like this, what I have shown in this slide. We can think about the three layer. At the bottom of the layer, let me take the pen. At this bottom of this layer is the thin layer, in which all the sensors, actuators, or maybe other small devices which are placed, physical devices are placed, and they form a multi-hub communication network, because one sensor, generally all the IoT things, IoT objects are resource constant in nature. So the objects could not have the flexibility, could not have that amount of capacity to transmit the data directly to the, if we use the cellular network, to the base station, or if we use the Wi-Fi to the access point, or any other router or gateway which is placed at the edge of at the end of this lower layer network. So this is the lower part. Okay, so they may not have this capacity, so we need to form the multi-hub scenario as shown here. This is multi-hub. So many relay is working in between. The ultimate objective is to transfer the sense data, the capture information to the analysis unit, or maybe the server or the application domain or user who is using. So that the application could give the feedback, or it can store for future use. So this is the things layer. Then coming the edge layer, this in between. Edge layer is nothing but the few devices, few nodes. Maybe we can think about the gateway, IoT gateway, or the router which is placed, or maybe some sort of server, edge node, storage server, or application server. But we have to keep in mind that these are not resource constant as the things layer devices are, as well as at the same time these devices, these edge devices, may not have that amount of resource which we assume to be inside the cloud or data center. So that's why these edge devices could perform limited storage, limited application, limited computation. And if we need to analyze the huge amount of data, the computational complexity is very high, then we have to send this data to the collected information to the next layer, which is the cloud layer. And inside this cloud layer, we assume that, or it is generally considered that it has enough amount of resources, and we can use those resources to perform any kind of activity, starting from the analysis to store to compute something. So then the feedback could come following the reverse path to the actuator or the sensor, where we need to do some additional activity based on the collected information. So that is the traditional way from things layer to the edge layer to the cloud layer. So now, what are the different components in this whole IoT ecosystem? Obviously, these sensor, actuators, microcontrollers, all the things are there. And also, we need to have some software, some protocols which will send the data from from device to the gateway to the cloud. Basically, it is all things are coming inside this IoT core. and this protocol inside this IoT core. And we could have the gateway, because if we want to access the cloud, we need to have this gateway. Then we already have mentioned about the cloud. So this cloud, inside this cloud, we could have this data analytic engine, which will analyze the collected information, collected data, to give some new business idea, to give some new insight inside this data, which is not visible in this, using this bare eye, or maybe using just seeing the data, it is not possible to understand. So that type of things can be done by this analysis, and we need to have some visualization application or some visualization interface, so that the user can see the application, user can give the command, user can see the collected data, or maybe the feedback which will get after analyzing. So all these things, so user interface. So these are the 5 major components in this IoT ecosystem. Any IoT application design, we need these 5 major components. Except these 5, we have another 2. One is the IoT architecture, and another is the IoT framework. Now this architecture, what is the need of this architecture? The first thing we have to understand, suppose we want to develop one IoT based smart system. Now let us take simple example, which we know, everybody knows. We want to build a house. Now what I will do at first, whether I will go to the market and start buying the different components, bricks, sand, or iron rods, or I will start interacting with the person who will build the house. So all these things, whether I will do, or at the beginning I will decide what will be the plan of my house, where I will put the bedroom, where I will put the kitchen, or where will be the other things will be placed. So this design generally we do at the beginning, and the importance of this design, there is no need to mention the importance of this design. If we do not have this design at first in hand, later on we will see that okay, this plan has been designed in so problematic manner, so there is a space utilization is very less, or maybe the difficulty to access one space from the other. So there will be the vulnerability point, so the house will remain open to the intruders, so that things will occur. Similar thing can occur here also in IoT system design. So that's why we need the architecture at the beginning. So this is nothing but the graphical design, what I have told with respect to building here. It does not mean that okay, where I will put the sensors, that also important, that also comes in architecture. And not only that, the how the sensors will communicate, or who will communicate with whom, so that interaction also needs to be designed here. And the last is the IoT framework. This, in this domain, basically we will find that all the big giants, all the big companies, MNCs, are working in this IoT framework, because this IoT framework is nothing but the tool or the environment which is provided to the user to design the IoT application in much easier way, much faster way. So that is the IoT framework. It gives the whole framework as the abstraction. User can use that framework and to design its own application in very easiest way. So that's why you will find Microsoft, Google, Amazon, Cisco, IBM. Every company is providing different types of framework for the user, for the not only the user, for the business organization also. Those who wants to design different business different services for the user. So they provide this framework to design these services, to design this IoT application. So all these 7 components basically are considered as the IoT ecosystem. Now, in today's lecture, I will mostly focus on the IoT core, where this communication, data transmission, data transfer from one node to the other, the protocols are coming in picture. So that is the focusing point in today's lecture. Now, how this data flow occurs. Basically, as we have seen, from things to the connectivity, look through the local connectivity, it goes to the gateway as it is shown here. From things to gateway through the local connectivity. This local connectivity, I'll come to that in detail. And then from edge gateways or edge devices, if you want to access the cloud, if you want to access the huge amount of resources available in the cloud, you have to go through the Beccal core network. So that is the basic data flow, and the command will come following the reverse path. The first question is how this data flow occurs. That is the data flow we have understand from the system design, how IoT works. But how this data flow occurs? The very short answer or the simple answer is using the data and networking protocol, which is the topic of this discussion, this lecture. What are those data and networking protocols? So the basic idea of data protocols is that how the devices are connected to communicate each other. So transfer the data from one device to the other. So that is the protocol, that is the rules. Protocol is nothing but a set of rules which needs to be followed by the devices to communicate with each other. So that comes under the data protocol. We can think using other idea also, that is that we can think about the data protocol and that these are nothing but the application layer protocol. And the network protocols are that type of protocol which are used to communicate, which are used to form the network, which are used to transfer the data through the network. Means there is a multi-hop scenario. There is a network formed using multiple nodes, not only the 2 devices, multiple devices are there. So it will form a network, and the data will be transferred from one device to the other. And the source and destination are, these 2 devices are not directly connected. They are connected via multi-hop path. So in between there could be many more nodes. So in this scenario, whatever protocols, whatever rules we need to design, those protocols are called basically the network protocols. For example, Zigbee, Bluetooth, BLE, which we know basically, BLE, LoRaWAN, or 6TiSCH, in short 6Ts. These are coming under these network protocols. And for data protocol, MQTT, COAP, WebSocket, and traditional HTTP, which we use in our TCP/IP network, computer network also. But the IoT version of this HTTP is also coming under this data protocol class. I will discuss few of them little bit, and also discuss in such a way that we will be able to understand the whole network flow, the data flow. So first, I will concentrate on the access network. So to understand it very easily, I have given the example of the access network used in internet, traditional TCP/IP network internet. Let us consider one institutional enterprise access network. This IIT Guwahati. It has one enterprise access network. So ISP provides the internet, and that internet comes to the enterprise access network via one institutional router. So that is the maybe one or multiple routers, but that router plays the main role to connect this enterprise network with the ISP, external internet service provider. And then whatever devices are placed inside the enterprise access network, they basically will be connected to that router, because to access the internet, all traffic should go through this institutional router which is placed at the end. Now inside this enterprise access network, we could have the Ethernet, we could have the wireless also, which is available basically in all enterprise access network. Both type of network is available. Wireless access point is used to connect the Wi-Fi wireless devices using maybe the Wi-Fi network, Wi-Fi protocol, and Ethernet switches. Ethernet switches are used to connect the system through the wired line. We could do inside the enterprise also, we could have the internal web server, mail server, or different other proxy server, different other servers also available that can also be accessed. So this is the type of access network, and the main objective of this access network is to connect the subscriber, because ultimately someone at the end, one user, is using the services. This connect the subscriber to their immediate service provider. Service provider may be the outside, inside the internet. So we are familiar with the different types of access network in internet. Residential access network, as we have seen, DSL, ADSL, FTTH, fiber direct home. This is the FTTH. Maybe dial-up. Earlier days, initial days, we had this dial-up, but nowadays maybe we are not using satellite. So this type of access network is available. Enterprise access network, what I have shown here, Ethernet and Wi-Fi mixed together, basically Ethernet. And we could have the mobile access network for wireless mobile devices. For example, the cellular network, WiMAX could be another mobile access networks. So I have just tried to mention this in this IoT lecture so that we can relate, we can understand in the IoT scenario also. Now coming to the IoT access network technologies which are used in IoT. Let us one smart home or smart building, monitoring the different different parameters inside this smart home or smart building is shown here. Maybe one air quality sensor is placed, smoke sensor is placed inside the maybe different places of the building. Temperature and humidity sensor is there. Maybe for the security, we could have the door sensors. And suppose in a smart home, we could have the water sensor also, we could have the power sensor. So there are different types of sensors we could place inside a smart building, smart home. And they could be connected with a gateway. As if we consider it is a very small area, then directly they could be connected. If we consider it as a larger area, smart building or smart apartment, then sometimes we need to have the relay in between. Let us assume the directly connected with the gateway, and this IoT gateway will help us to connect elsewhere. And now how they are connected, how these sensors basically are connected. These sensors are smart sensors. These are not just sensor having the sensing capacity or capability. It is also having the communication capability. So that we could have different types of technology. access network technologies. For example, many of us are familiar with the Bluetooth, BLE. Many of us are familiar, and it is commonly used, heavily used. Also, many of us are familiar with the Zigbee. Those who are at least have seen different types of application, IoT application, they have used the Zigbee. So this is mentioned, I have mentioned that this is the Zigbee. And also we could have the Modbus, which is generally used in factory or the automation, okay, industrial domain, generally use the Modbus. This is because this is a wired communication, and this dotted line is showing the wireless, and this is wired communication. And we could have the 6TISCH. So this is again one open standard protocol, which is also used in IoT domain. So now by this, we could have different types of access network technologies which are used in nowadays for IoT systems or for IoT application. I have mentioned few. There are many more. As I have mentioned, these are 6LoWPAN, LoRa, and if we consider the cellular based, then NB-IoT, 5G, and if we consider the Wi-Fi related, then Wi-Fi and this Hello, which is the IoT version of the Wi-Fi, and there are many more you will find in the market: Thread, Sigfox, sub-gigahertz, okay, wireless HART, which was the initial technology for IoT related works. So now one confusion will occur, okay, there are so many present in the market, so which one is better or which one needs to be used in my application? How to understand, how to compare them? So there comes that the criteria by which we generally compare them, the communication criteria. We could compare them using the communication range. We can compare them using the frequency band they use for communication, or if we have the resource constraint devices very much resource constraint in nature, then we could also compare using the power consumption. Generally, IoT devices are also resource constraint in nature, so power consumption also very important. Other type of parameters are also there: topology, constant device name, and constant network, nature of constant network. I will compare few technologies following few criteria. For here, I have compared the Wi-Fi, BLE, Thread, sub-gigahertz, which is designed by the TI. There are other design also. I have compared based on the TI design: Sigfox, Zigbee, and LoRa. Now let us consider the range, communication range, the second row. Wi-Fi 100 meters, access point to a device. BLE maximum 750 meters. Thread 100 meters. Now coming to the gigahertz, sub-gigahertz TI device, 4 kilometer. If we use the Sigfox, it is around 25 kilometers. They claim, at least the manufacturer or the those who have proposed this access technologies, they claim this distance, 25 kilometer. Zigbee could be 130, 150 meter, and LoRa could go up to 10 kilometer. Now, based upon the requirement in my application, I have to decide which range is suitable for my application. If my application is a smart home application, then we don't need to go kilometers in this domain. We could have the meter, 100 meters, 130 meters is enough. Now, if we deploy some outdoor sensors for sensing the huge area, maybe in a metropolitan area, then obviously meter will not work. Then if we use the meter based technology, means the technology which can communicate up to few hundred meters, and then we have to have many relays in between, so which is not a very good design again. So it is better to have the kilometer range. So for sub-gigahertz, 4 kilometer, LoRa 10 kilometer, Sigfox again it is also sub gigahertz band, 25 kilometers. Okay, so that we have to decide. Now let us consider the frequency band. So again, few frequency band is the unlicensed band, few technology uses the licensed band. If I want to design one application using unlicensed band technology, then we cannot go for NB-IoT or sub gigahertz given by these TI devices, because those frequency band means which frequency bands in sub gigahertz band also we have the unlicensed band, but in general the band which is used by the sub gigahertz or Sigfox, they are not in the unlicensed band. They are licensed band. We cannot use that for our application purpose until and unless we take the permission from the regulatory authority who gives the permission to use which frequency licensed band can be used for this application. If we can go with the 2.4 gigahertz, which is a very well-known band, which is unlicensed band, anybody can use for their application, for testing, anything, for anything. Okay, LoRa also use 868 megahertz sub gigahertz band, so 868 megahertz, which is also unlicensed band. But there are few other band which is used in LoRa. Those bands are not unlicensed. So those are licensed band in India. So that's why what I have mentioned here, that based on the requirement, we have to decide that which technology is suitable for my application. Now, if I go for the power consumption, which is a very much important with respect to IoT device, IoT network application, then again we will see that few devices few technology consumes huge amount of energy. Few technology can run with very less amount of energy. For example, just see Wi-Fi. Why Wi-Fi is not suitable for IoT network? See the range of energy it consumes when it is idle. Still, it is to 45 milliampere. Transmitting also more than 200, receiving also more than 200. Now, if we use the LoRa, let us consider LoRa. See the range 1.4 when it is idle, when it is not using anything. It is idle. When it is sleeping, microampere range, and it is 1 to 2 milliampere when it is idle, not transmitting and receiving. But when it is transmitting and receiving, it consumes little bit more than the sleeping and idle scenario, but much lesser than the Wi-Fi technology. So that's why using Wi-Fi, we cannot use the IoT devices which are battery powered. That's why the Wi-Fi, because we need to recharge them frequently. Huge amount of energy it consumes. But if we use the LoRa or maybe the other Zigbee, and then we have seen that they consume much less energy. So battery powered nodes are also suitable. So therefore, it is also one challenge to design the communication protocols in such a way for IoT that they will take care of this energy consumption. Means my protocol should take care of this energy consumption of the devices. So now I will concentrate on this one technology, IEEE 802.15.4, because this is open standard. Okay, so, and also it is suitable to use with the traditional TCP/IP network. I will come to that. Now in IEEE 802.15.4, this is a technology, low power technology, which is designed by this IEEE 802 LAN and MAN group. Basically, the same group who has standardized the Wi-Fi. So 802.11 technical number, as you can see here. So they have standardized this Wi-Fi technology also. They have formed this task group for low rate wireless personal area network, This is nothing but low data rate devices and low cost, and also they are battery powered nodes. They form the network and they use this standard which is designed by this task group 4. So basically it is initially targeted the PAN, wireless PAN. PAN means personal area network. So which is lesser than the LAN, which we are familiar, local area network. The personal area network small, just very small, maybe inside my house. The personal short distance, low power device could be used, and there is no infrastructure. Means ad hoc networking is the main structure topology, and also we should have the wireless wired features also. Okay, that initially they targeted, but nowadays in the later version, they have also they removed this personal area network because nowadays this same standard is used for wireless network, traditional wireless network. Now this 802.15.4 Open IEEE standard for low power and low rate network, initially they proposed this for, as I mentioned, that physical layer and MAC layer in the communication protocol stack. This standard, initially whatever they proposed, Zigbee uses this standard at the beginning, and Zigbee shows the idea that okay, we can use this technology, physical and MAC layer protocols for designing different type of application independent of the other layer. Means we don't need to have the other layers in the traditional TCP/IP communication protocol stack. So this IEEE 802.15.4 is used by following the Zigbee, is used by many other technology protocol stack. As I mentioned, Zigbee and the IP version of the Zigbee, 6LoWPAN, wireless heart thread, 60. There are many more. But one common disadvantage remains inside this 802.15.4 is that it is less reliable, unbounded latency. It provides unbounded latency, and also it is susceptible, means interference and multipath coding cannot address properly, and also the frequency hopping technique was not there inside initially. Means only one frequency they use. If you use the only one frequency, then the problem is anytime hacker can jam this channel, only one channel. So I will first show the different layers, physical layers and MAC layer very briefly in 1-2 slides. That what is this standard all about? This is the standard physical layer. It defines that 6-byte physical layer header. Means whatever communication it performs, it follows the frame or some sort of message frame data structure is there. So this data structure is, it is having one header part, it is having one payload part. In header part, it is 6-byte preamble, start frame, delimiter, frame length is the header part, and then this basically this part is used for synchronization, and this is the frame length header to understand where it is. It means what is the length of the whole frame, and then the payload, physical service data unit. So this, in this standard they have used, I am focusing 2015 standard. Now the latest standard is published in 2020. Almost the same things remain, but few modifications also are there. 2.4 gigahertz, they have used 16 channels, 915 megahertz, 10 channels, 868 megahertz, 3 channels. The data rate of this gigahertz and 915 megahertz of 250 kbps, and in the 868 megahertz it is 100 kbps, around 100 kbps. And the modulation scheme which is proposed for this different modulation scheme, orthogonal QPSK, BPSK, or sometimes it is also used the ASK, amplitude of shift king, phase shift king, which is mentioned binary phase shift king, BPSK, along with the DSSS, means direct sequence spectrum technology. This is another technology. I am not going into the detail of this technology or the different types of modulation schemes, but just for information that this is the overview of the physical layer design. And for the MAC layer design in the 802.15.4 standard, as I have mentioned, that it follows the encapsulation mechanism, means whole MAC layer frame. So this whole MAC layer frame will be used as a payload in this physical layer service data unit, means inside this payload part of the physical layer frame. Similarly, when you use the upper layer, so MAC layer also has one payload part, this payload part, the upper layer frame should come inside this. So it is the structure followed for modularized protocol structure in layer. And in this physical layer, as I have mentioned, only 127 byte is the maximum size it can support for low power network. The maximum size of the MAC frame could be 127 bytes. So following this, the MAC frame is designed in this way that, okay, this is the MAC header part. Again, the same structure, MAC payload part, and some footer, means some error checking option is there in the data link layer, the MAC layer with respect to the wireless network. Again, I am not going into the details of each components, but this is the basic. The main task of the MAC layer, MAC IEEE 802.15.4 is to manage the physical layer channels which are available for this network, and also the different MAC layer activities, network beaconing, means any node association, disassociation with the network, and proper reliable data communication, and some sort of security, as I mentioned, that this is used for error detection, error checking, and few this is just error detection. Error detection is not directly the security. Security part is there. Security is not mentioned here. The security, if we use the security, then basically there is an auxiliary security header which is placed in this MAC payload part. So if we place this security, as it is auxiliary, if we want to use the security, we can use. If we do not want to use the security, we can omit. Instead of that, that space can be used for payload also. So what type of security it defines? That it uses the encryption, cryptographic security method. The advanced encryption standard AES 128-bit key is used for encryption and decryption. And also it is use the data integrity using the message integrity code. Sometimes we also call message authentication code. Okay, so that is the method, the security mechanism it follows. So this standard is designed by this IEEE. But what is the limitation of this standard? The limitation, as I have mentioned in short, that it does not give the proper understanding about the latency. What time it will take to transfer my data from source to the destination, following these protocols, following these technologies. So that this is not bounded, this is not deterministic. That's why unbounded. Non-reliable communication, because it is basically using the CSMA, which is the random channel access mechanism. Again, carrier sense multiple access collision avoidance. This mechanism is the default protocol which is used in Wi-Fi. But this protocol is good enough. But this protocol also has many disadvantages. And those disadvantages are not suitable for resource constrained IoT network. So non-reliable communication. no protection against the interference and multipath threading, because as I mentioned initially, it uses only single channel. So here interference means traditional interference, unintentional or intentional, hacker or attacker intentionally interfering. So both could happen. And multipath threading, it is a physical layer phenomenon. I am not going into that detail also, but that also disturbs this design, traditional design, because it is using the single channel which can be predicted easily by anybody, any node also. And in the multi-hop scenario, it uses the powered relay nodes. That means because a relay node needs to remain active always, because relay node does not know when the data is coming or when I need to transmit the data for the relay the data for the next. So traditionally, the powered relay node is used in this design. So that is also not suitable, because let us assume we have placed on one IoT network in the hilly region, on the top of the hill. So it is very difficult to provide the power relay node at the top of the hill. We need to bring the electricity over there, which is very difficult. So this is the base. These are the basics. Also, there are a few other disadvantages, but these are main. So the modification occurs in around 2012. This IEEE modified it, proposed the amendment. The TSCH concept they brings, and this in this TSCH, I will briefly tell that full term and the corresponding activity, time slotted channel hopping. So that means from the name we can understand that communication they have decided to be done using some time slotted manner. So the whole time they have divided into multiple slots, as it is mentioned here in this 0th slot, first slot, second, third, and n number of slots together forms a slot frame. And this slot frame will be repeated over time. Here, 2 slot frame is shown in this picture. Each slot frame consists of 4 slots only. Traditionally, it is 101 slots in IEEE 802.15.4 ETSA standard. But for the sake of diagram, I have shown here only 4 slots. And the duration of each slot is suitable to transmit one data from the sender to the receiver and the corresponding acknowledgement receiving from the receiver. So that's why you can say that data is transmitted, and for transmitting these offset, guard time, all these things are required. So again, no details, I am not going into the details, just to understand that one data is transmitted, one data packet, and the corresponding acknowledgement is received. And the time which is required to perform this activity is the slot time, only single slot. So the mechanism it proposed that, okay, the whole communication will be performed following this time slotted access. Multi-channel communication. So here, as I mentioned, that in the physical layer there are multiple channels available in each frequency band, but initial standard used only one channel at a time. In this modified standard, the multiple channel also can be utilized parallelly if they are not interfering, because if they are physically located in different places, obviously if we use the same channel also, the nodes, the communication will not interfere each other. We can use the same channel. So that's why along with this time axis, it has also considered the channel offset, which at this moment let us understand that over 0th channel, 1 second, here 5 channels are shown in this diagram. So 0th time and 0th channel could be used for one communication. Here it is shown that data is communicating from node E to node C and from node G to node C. So this is, and let's see, and this diagram, it is showing that at the same time, another communication also going on from node L to node B, the channel is different. So there is no question of interference. Rather, there are another communication also from I to D. So there is no question of interference because every communications are using different channel. I will come to this two here, two part here. I will come to the next slide. Channel hopping means one set of sender and receiver could change the channel after transmitting its present packet. The next packet can be transmitted using the another channel. It is not fixed. It is not like that, that okay, one channel has been given to a sender receiver pair and that channel needs to be used lifelong. It is not needed here. This feature is used in this standard. What is the advantage? Obviously, we can understand easily that if one sender and receiver is changing its channel, communication channel over the time, then it will be difficult for the attacker to understand that which channel it is going to be used at this moment. Shared and dedicated slot. So this is basically dedicated slot, means this channel, this time is used for only one communication from L to B. And this slot, see E to C and G to C. So basically the C node is the receiving node. E and G, we can think about the graph, the child node. So when E is communicating with the C, G cannot communicate. When G is communicating with the C, E cannot communicate. So that's why this slot and this channel can be shared among these two links. So there, this possibility also have been introduced in this design. And the low duty cycle, as I mentioned, energy is very important. So low duty cycle means it is already decided when need to be means one node when should switch on its radio, when it can go into the sleep, when it can go into the idle time. So everything is decided. So one schedule must be there which will tell this information to every node. So the node will achieve low duty cycle. Energy consumption will be very less. All these features have been introduced. And as I mentioned, that one schedule needs to be there, which will decide that okay, when this node will go into the sleep, when the node will go into the receiving mode, when the node will go into the transmission mode. So that schedule is nothing but a scheduling mechanism, so link scheduling. And this scheduling, the existing link scheduling scheme for other network but traditional TCP/IP network is not suitable because the existing scheduling does not consider the channel hopping. They are not designed keeping in mind the resource constraint node and network in nature. And also the channel utilization is not efficient with respect to the availability of the multiple channel because there are multiple channels available. So new scheduling scheme have been proposed, and for that we can see this protocol on the top of this IEEE 802.15.4 ETSCH. There is another sub layer we can consider. That sub layer is basically responsible to design this scheduling link scheduling scheme here. One scheduling example I have mentioned here as let us consider this is the topology and corresponding scheduling is this one possible link schedule. And from this schedule we can understand that okay, let us consider the node B. When this node B should remain active, when it can go to the ideal, it can easily understand if the node B had this whole structure. So here B is participating, here B is participating. So then at 0th slot and at second slot, it should remain on. Rest of the time, it can go and sleep. So power duty cycle will be very less. Means power energy consumption will be very less. And as I mentioned that this is dedicated link, one communication, and this is shared link. Okay. I think now the first part of the discussion, that up to the access technologies, physical layer and MAC layer, following the open standard, which I am following basically, TSCH IEEE 802.15.4 TSCH standard is completed. And because this lecture is for continuous 2 hours, so I want to know from the organizer, so should I give some break time or I can continue?
So we can have a short break of 2 to 3 minutes and then we can start.
Okay, so okay, so because now I will start. Internetworking means when the networking other protocols, network protocols and data protocols will come. I have covered the access technologies part in brief. Now the protocol part I will discuss. So let us have 2 minute or 3 minute break. And now it is the time, I think 11 already, or 11 past. Then we can start around 3 minutes or 4 minutes later.
Okay, so we will start by 11:05. So is that okay?
Yeah, that's okay.
Okay, sir. Thank you, sir.
Okay, welcome back to the next session. So far, I have discussed about the access technologies. Basically, from my discussion, I hope you have understood. I have tried to cover this, the basic of Zigbee and 6TiSCH. They both of them uses the IEEE 802.15.4 low power network standard at the bottom in the communication protocol stack. So these two I am focusing. Now, from this example also, that let us, I want to monitor the smart home sensors, the data in real time remotely. So I could have one application designed for the mobile application for the smartphone or maybe the desktop also. And I want to access that in my application. How to get this? This is the question, how to get this? So the simple straightforward answer is we could utilize the existing internetworking infrastructure which is available, cellular based or IP based infrastructure, or we can directly deploy our own infrastructure to connect with the IoT gateway, which gateway is connecting the all the sensors inside the home. So traditionally, both of the facilities are available, and it is very important to know that if we want to deploy our infrastructure, so the capital expenditure will be very, very high. People generally follows the existing infrastructure, cellular based or IP networking based infrastructure to use for remote access to these IoT sensors data or to give some command to the actuators. Now, we are very much familiar with the Zigbee protocol, and I mentioned that Zigbee follows the bottom layer IEEE 802.15.4 standard. This is one device designed by manufactured by DZ International. So Zigbee module, XB module. So it is following the Zigbee protocol stack. And this Zigbee is initially designed non-IP internetworking protocol, means it is not going to use the IP, traditional TCP IP. So instead of that, it has own protocol stack. So you have to design the application and the internetworking support, which I mentioned that this is the part. So this network support, including the security. So it has its own proprietary protocol stack. So that was the initial design. So in the network, internetworking, or you can say the data communication through multi-hop nodes, multi-hop network, they use the AODV routing. Again, AODV routing is initially designed for not for this Zigbee. It is designed for the other type of network, but that routing, ad hoc on-demand distance vector routing, the whole routing scheme. I am not again going into the detail of this routing scheme, but it uses this AODV routing mechanism for sending its data from one node to the source to the destination. And for security is used same AES encryption as it is mentioned in the MAC layer, which is used here inside this IEEE. Zigbee also provides security in the network and application layer, and that is all this declaration is proprietary, means Zigbee did not disclose how they are going to use this. Basically, what they have informed that, okay, they have this vendor specific application design, means whatever they have provided, it is having few features. One is the vendor specific application design, and the platform stack is also very good in that manner that, okay, it can support different types of application. And at the bottom, MAC and physical layer, Zigbee is using the IEEE specification. So whatever IEEE 802.15.4 supports, Zigbee also supports the same, including security, including size, including data rate, frequency band, everything following the same. Only this part is designed by the Zigbee platform stack and Zigbee vendor specific application. Means any vendor can design their own application and that can be fit for Zigbee if they follows the APIs given by this Zigbee. If the problem is this is very means this is not using the IP standard IP protocol which is already available, and the interoperability means one vendor is designed one application, one IT solution using the Zigbee is not suitable or interoperable with the other design by the Zigbee using the same Zigbee, because Zigbee is not a device. Zigbee is basically a protocol stack which is given here. So that's why this is not, these two solutions designed by two different vendors are not interoperable. And also the infrastructure, the organization needs to provide the infrastructure, because it is not going to use the existing infrastructure for long distance communication. Means from long distance means from geographically far away, from maybe Guwahati to Delhi. One part is deployed here, another part is deployed in Delhi. How to communicate in between? So the Zigbee is not using the existing deployed infrastructure. Deployed infrastructure could be the cellular network. Deployed infrastructure could be the IP network. Zigbee is not using. Deployed infrastructure could be the satellite network also, not using. So that was the problem. That okay, it is standalone application running fine, local area, okay, it's fine, but for long distance communication or for geographically two different region, if any organization has two different offices, so Zigbee type of Zigbee application is not suitable for that. So Zigbee modified it to make it IP version applicable. So that is the Zigbee IP, the later version. Again, I am not going into the details of Zigbee IP, but as from this understanding, from this discussion, what we have understood, that open standard internetworking infrastructure is suitable for IoT network also, for IoT application design also. So one open standard internetworking infrastructure is the IP-based infrastructure, and the advantages of IP-based infrastructure, we are very much familiar. It is already standardized, versatile, ubiquitous, and it is stable network, very secure network. Means all these services are already available and running. We don't need to take care of that. So this IEEE, or those who have proposed this low power network, wanted to utilize this existing IP standard. So now from this diagram, what we can understand, that upper layer is the existing TCP IP, and the bottom layer, the data link and physical layer, is the low power and lossy network. The short name I have written here, LLN, low power and lossy network, and following the IEEE 802.15.4 standard, means including the amendment, this amendment, that is enhanced version. Now again the problem occurs. What is this problem? That okay, this TCP IP was developed or proposed long back, and IEEE 802.15.4 was proposed recently, around 2010. We have seen that this amendment E, this version actually published in 2012. So now, as these two are proposed later, and these two again, this network is also not proposed, keeping in mind that it will be connected with the IP. So the problem is this interoperability, means the connection with this, how to utilize this. The one problem, a technical problem, is the frame size. Okay, the minimum size supported by this IP is 1024 bytes, and the maximum size, as we have seen already in previous discussion, 127 byte, and it is following the encapsulation concept. This encapsulation means this whole IP packet should go into the payload part of the MAC layer frame. And this is 1024 bytes, and it is only 127 bytes, including this header and footer. So how to fit this? This is the problem, and obviously we need the adaptation layer, which is nothing but to make it applicable for low power, means make this TCP/IP applicable for low power and lossy network. We know that 6LoWPAN is the protocol which is proposed for this adaptation layer, and this 6LoWPAN is used. This is again open standard following this IEEE 802.15.4. So it is proposed. 6LoWPAN network also can be formed. That again, I am not going into this detail. But yes, if we use these open standard protocols, then we can form the 6TISCH network. In this, it looks like that multi-hop network, low power and lossy network. This is the IoT network, and it is in the bottom. And it could be connected with the internet through the backbone router, and through the gateway, it could be connected with the internet. And once it is connected with the internet, so it can communicate far away with the nodes placed in far away from the other node. And source and destination can be placed in two different places geographically, into different regions. And when they are communicating, the communication protocol stack looks like this. The physical and link layer, it is IEEE 802.15.4. And as I have mentioned, for scheduling, we need to have this MSF is one scheduling scheme. And again, I want to mention here, this MSF has been proposed, or you can say the RFC has been published in last year, 2021. Last year it has been published. RFC has been published. Okay. And in the network layer, 6LoWPAN is for adaptation. An IP protocol can be used, and using this IP for low power network, another version of the routing protocol is the RPL, which is used. And in transport layer, we use the UDP. Also, we can use the TCP. And for the application layer, as I mentioned, the different data protocols have been proposed. COAP is one of them, Mqtt is another of them. I will discuss Mqtt and COAP a little bit. And also I will discuss 6LoWPAN and RPL. So now, so far, the bottom part I have discussed. Now I am going to discuss this upper part, overview of the upper protocol layers. What is this 6LoWPAN? As I have mentioned, that it is the adaptation layer protocol. The full name of this 6LoWPAN is IPv6, because the target was IPv6, not IPv4. Again, why not IPv4? The addressing range in IPv6 is much bigger than IPv4. And in IoT application, we know that the number of sensors, smart objects, could be very high. Very high means very large area also if we target, then also, or even in small area also, we could have the huge number of nodes. To give them the proper IP, IPv6 is used. So IPv6 over low power wireless personal area network is the full name of 6LoWPAN. And it is open IoT internet networking protocol. As I mentioned, the basic goal is to support these resource constrained devices, small devices, to be accessible through the IP network, through the IP means TCP IP network. That was the basic goal. And what it defines technically in the adaptation layer, what it is doing, it is basically means optimizing the size. The header compression mechanism is proposed inside the 6LoWPAN, so that the size can be reduced. And it can be fit into the maximum size of the data link layer frame. So that was the basic objective. IPv6 header, TCP or UDP header, we can optimize, we can compress. This is the header compression mechanism. We can compress and we can put inside. We can keep only the required size, required field. All the other field we can remove. Then automatically size will be reduced. Again, I am not going into the detail of this compression technique. But I will just give some advantages of 6LoWPAN. The one thing is it is using open IP standard. So it can use all the open standard protocols, TCP, UDP, HTTP, SUAP. Initially, Mqtt was not open standard protocol. Mqtt was proposed by the IBM company. It was a proprietary thing. But later on, they have also published it for the open standard. And end-to-end access using the IP network has become possible because of this 6LoWPAN. Now, mesh routing, one to many, many to many, many to one, or many to many also possible in 6LoWPAN routing. It is robust. Self-healing means automatically it can heal the difficulties. Suppose one node is going down because of many reasons. Let us take one example of energy drained, or the full energy has been drained out. So one node is going down, so automatically it will heal the network. So how this healing can be performed? So that is also the part of the 6LoWPAN, means that's the advantage. And the other advantage is multiple physical layer support, means the 6LoWPAN is designed in such a way that the physical layer, even if it is designed targeting the 802.15.4, but still it can support the Ethernet. Maybe it can also support the Wi-Fi, which is 802.11. Okay, technical standard, IEEE 802.11. Sub-gigahertz. So different types of physical layer standard also it can support. So these are the main advantages. And this is the 6LoWPAN traditional architecture. So this is the 6LoWPAN network. It could have different types of devices, full functional, represented by different color. Yellow color is the full functional devices. Blue colored nodes are reduced functional devices. And the red is the gateway, IoT gateway, because through this RAID, it is going to be connected with the internet, which is TCP/IP, and there are different terminal servers, different users using computer, laptop, or smartphone, and also could be a server connected with the internet. So this is the traditional TCP/IP network, means how this 6LoWPAN is connected with the TCP/IP network, the traditional architecture. Now, one thing I need to mention here is the FFD and reduced functional device, means all function, all requirement are not running here in RF reduced functional devices. Suppose these devices, just from this diagram also we can see there are the least node, means leaf node with respect to the graph representation. So there is no requirement to relay the data by these nodes. So this relay mechanism need not be executed here. But these devices can transmit its own data, as well as they need to perform as a relay for the child, for the leaf nodes, because they are not leaf nodes basically. So that's why they are full functional devices. They can transmit its own data, also can relay. And these blue nodes are reduced functional devices. So this is a traditional 6LoWPAN architecture design. We can design this type of network. Now coming to how this multi-hop routing can be performed. So This low power and lossy network, as I mentioned already, they are following this IEEE 802.15.4 or low power Wi-Fi protocol standard. And these devices are limited in nature. All the devices participating in this network are limited resource in nature. The power, memory, and processing capacity is limited. And now how to transmit the data from one node to the maybe the server, or any command coming from the server to the actuator to the node. So it is shown here. So one routing protocol obviously required. That routing protocol, I am coming to that. That what is this routing protocol and why it is challenging? Why not we can use the existing routing protocol? Because in IP network also we have many routing protocol running. Distance vector routing, link state routing, different type of routing technology. So this type of routing technologies are used in IP. At this moment we are using this IP network, it is running. Why not that can be used here directly? So the problem is again the resource constant. The biggest problem is that these devices are resource constant in nature. And also the topology is very dynamic because the nodes are wireless device, mobile devices. But in general, TCP/IP does not support this dynamic topology. Means even though it supports the Wi-Fi, this moving devices, Wi-Fi supports the mobile devices. But still, if it is very dynamic connecting, again once it is connected and then again disconnected, so the performance automatically degrades. And sometimes these devices, these IoT nodes are deployed in harsh environment, which is not at all the considered in TCP/IP design, because we never think that okay our computer will be placed on the top of the hill or maybe in some inside the forest. It is not people does not think it. So, but in this IoT, it is the common thing that either maybe it will be placed inside the forest, deep forest. So it is deployed in harsh environment. So that we have to keep in mind. So battery power, and it is deployed in large scale. So the routing protocol needs to be needs to support this scalability. So keeping in mind these important features, RPL protocol has been proposed, which is very efficient. It can support the different link layer technology. Also, different LLN application requirement, means application could require that okay, my delay will be less, throughput, whatever the throughput, it is okay. Sometimes it may require no energy consumption will be optimized. A delay I can avoid. I can accept little bit longer delay. So different types of QoS requirement also it supports. It follows the distance vector mechanism, which is the same mechanism used in our TCP/IP network, and also together distance vector and source routing mechanism together. It is designed for it for means it the topology is formed as per the DAG structure, directed acyclic graph. So we can see one DAG structure is shown here, that okay, all the nodes A, B, C, D, E, F, all the nodes are placed, and LBR is the border router, means low power and lossy network border router. Means that this LLN low power and lossy network ends here. After that, we would have the IP, TCP/IP network, as it is shown in this diagram properly. So this is the LLN. After that, it is the internet. LLN border router. Okay, so now all the nodes will send basically all the nodes sensing the physical environment and sending the data. So it is the DAG. There is no cycle. We can see there is no directed cycle basically. And there is no directed cycle in this topology. So this is the DAG topology. It is formed automatically using this RPL structure because it is the convenient way to transfer the sensed information to the border router, and then from this border router to the application server or to the user who is accessing this data remotely. Now, as I mentioned, so now the data is going to reach to the application. So we should have some application protocol by which the application is running to access this or to utilize this service, this network protocol services. MQTT is one of them and widely used for IoT application. The full form of MQTT is Message Queuing Telemetry Transport Protocol. It is very lightweight and it is reliable, very cost efficient, and a very important few important features. I will come to that. That what are the important features? The one feature is it follows the publisher subscriber model, publish subscribe model, pub sub model in short we call. That means suppose one temperature sensor is placed inside the room, and user is getting this data, temperature data of the room periodically. That is the basic requirement. Then this publish subscribe temperature sensor basically publish its data, means send its data, the collected physical environment data to the intermediate, which is called the broker, the MQTT broker, intermediate devices. And this broker basically stores this information, keep this information for the subscriber. Suppose this user wants to know this data, so it will subscribe to this temperature, and this as it is subscribed, it will get this information. When it will log in, it will get this information from the broker. We can think it is just like our television system. It is almost similar fashion, publish subscriber model. Suppose different channel is publishing data, and television provider, this service provider, they maintains this information. Maybe I have subscribed for channel 1, channel 2. Maybe someone else has subscribed for channel 1, channel 3, not channel 2. So if I subscribe for channel 1 and channel 2, if I switch on my television and if I go to the channel 1, I will get the channel 1 data. If I go to the channel 2, I will go to get the channel 2 data. But as I have not subscribed, so I would not get the channel 3 data. It will ask me to subscribe first. Similar mechanism is followed here. That who is producing data is not dependent on the subscriber. That okay, I have produced the data, so when I am producing, subscribers should remain also be connected with the system. It is not required. Producer can produce, subscriber will later on will come and subscribe, or subscribe means initially it needs to be subscribed, but later on will come and will get the data. So it is basically the publish subscribe model, so works in this way. And asynchronous communication model, as I mentioned, that the publisher and means the two end devices here, the temperature sensor and the final user who is the subscriber basically. So they don't need to be online at the same time. They don't need to be connected directly, because they are in between one device, the MQTT broker, who is handling, who is controlling this. That's why it's asynchronous communication model. But in many systems, suppose many system we have seen that synchronous communication model means when I am sending the data, the receiver should also remain connected at the same time. For example, the telecommunication, telephone. When I am ringing to some user, so user also pick up the phone at the same time. But suppose email, I'm sending email, but the receiver needs to be online or needs to be connected at the same time. In between, there is a server who will keep this. So this asynchronous communication. When later on, when the receiver will come and log in, automatically it will get the email which I have sent. low overhead means this communication protocol has only 2-byte header, because header is the part which is used to control the communication corresponding to this layer activities, this layer functionalities. So it is having only 2-byte header, very small header size. So overhead is also low, because this overhead, this header part is not containing the data part. The data part, payload part is containing the data, which is the basic requirement for the user. But for performing this whole communication, header part is also required to control everything. And also it can, MQTT can support, means it can run over the TCP also. Generally it follows the, sometimes it also use the UDP, run can TCP also. In this case, the 6-LoWPAN needs to be used in between. So that is the technical part. So this is the basic idea of MQTT. One use case I have mentioned here, light sensor as a publisher continuously sends the sensor data to the broker. Broker will be there in between. And building on control or application, that control application at this moment, it is collecting data from the light sensor. So we can think that this is a subscriber. Okay, so it is receiving the sensor data from the broker and decide to act. Maybe the light sensor gets some data, and based on that, it wants to switch on the camera, which is placed inside the room. So it needs to give back the command. It needs to send the command back to the camera. So it will send this activation message of the camera through, again, this command also will go through the broker, So this is one use case for MQTT. And because of this lightweight and also very efficient asynchronous communication model, publish subscriber model is used. So it is used by many real life IoT framework provided by different organizations like Amazon, IBM, Microsoft. I have already mentioned about IoT frameworks. They use this MQTT for application layer protocol, means for the design of different application using this MQTT application layer protocol. One more application layer protocol is the COAP. So this is constrained application protocol, and this is initially designed, I mean, from the beginning it is open standard, designed by IETF organization. So constrained application protocol, from the name we can understand that it is designed for constrained devices, for constrained network. It follows the similar structure of HTTP, because HTTP is very much familiar because of the World Wide Web, WWW. HTTP is very much familiar, and people are habituated to use the HTTP. They know the different features of the HTTP. So COAP also was designed keeping in mind that, okay, many features has been taken from this HTTP. Just few modifications have been performed. So it follows the request response mechanism, just like HTTP request response. It sends the request to the server, means client send the request to the server, and server gives back the response. So COAP also follows the similar structure. So therefore, there is a very good, you can say, the interaction between the HTTP and the COAP. We need the proxy. Just a minute. COAP also uses very small header, so overhead also is very less. It uses one important concept, which is called the restful architecture. So as it is mentioned here, this rest from top to bottom, means from one side to the other, end to end. So it is the restful architecture. So again, restful architecture is a type of communication, which is used for resource constant devices and also for different application designed for the internet also. It means it will not use everything from the HTTP. So whatever is RESTful, it will use that one only. COAP supports the synchronous communication. COAP supports the asynchronous communication both. So therefore, COAP is very important. One scenario on example I have mentioned using the COAP request response model. Suppose there is a means inside the smart room. Okay, thermostat has been placed, which is measuring the temperature. So when it is measuring the temperature, it needs to send this temperature to the client. So request is sent using different messaging format is there. One message name is called conformable, and another is the called a non-conformable. So conformable, non-conformable, either one. And which one is used when that I'm not going into that detail, but some messaging structure it will follow. Request will be sent based on this inside this message structure, and the response will be sent back because this is request response mechanism. Response will be sent back using either piggyback mechanism or maybe the separate response message will be used. Okay, separate response message will be used depending on the requirement. If it is required immediately, then it will be piggyback with the next frame, or if it is not immediate, then the separate response message will be formed, it will be sent back. And it uses the similar URL, similar, not same, I am telling the similar URL structure which we are familiar with HTTP. To see in case of HTTP, see this URL structure COAP. Instead of HTTP, it is mentioned COAP, and see this almost similar. Almost port address is there, okay, device name, and which parameter it is subscribing, means for which parameter it is collecting data. So that is the name, so is used. So now from this also you can understand this client is sending this request using this URL, and then the data will be sent back to the client. So this request will go. This is the request is going, and the response is coming back to the client. And here the sensors, as I mentioned, the thermostat inside the maybe the small room is considered as a server, because the client will, the user application will send the request to the thermostat, and thermostat will give back the response. So this is the all about the data protocol and network protocols, which I have tried to mention, which I have tried to explain following the IEEE 802.15.4 standard and the Open IP standard. I did not discuss the UDP transport protocol because UDP is the protocol, the same protocol which is used in our traditional internet. Same protocol is used for the transport layer in IoT, Open IoT standard. So in this now I will just show a few testbed which I have for doing the research, and my students are using this testbed. This is one testbed I have in following the 802.15.4 standard. I have already more than 30 nodes. Few are launchpad, few are sensors. Means just launchpad we can use as a relay node also. Or we can attach the sensors, and few sensor tag is there already. Inbuilt sensors are there many. This is sensor tag, and this is the launchpad, and these are the device I have purchased from the Texas Instrument. Using this, we can do the whole communication. Here you can see this network is formed. One network is formed inside this. You can see the multi-hop communication protocol is formed here. This is the test bed, and also I have the LoRa test bed which is used. So see, these are the LoRa devices. On the top of LoRa devices, this one on the top of the Arduino. Arduino on the top of the RPI also there is a LoRa. So RPI based, and this is the gateway. With this, we can use the different sensors and actuators connected with this. I have tested also for different application using this test bed. I have, and this is just one application which is designed long range monitoring and control using the LoRa communication. Because LoRa communication is LoRa technology can cover at least 5 to 10 kilometers outdoor, 5 to 10 kilometers. And this is very basic IoT setup which we use for teaching purpose or for a demo purpose using ESP8266, or maybe this is Node MCU. Node MCU, ESP8266, or RPI, okay, Arduino. So all these things we can use. Along with them, we can use the sensors to collect the information and IoT design the IoT application. We can use the cloud, ThinkSpeak cloud, which is available freely. We can get an account there, and we can do the different types of IoT protocol, IoT application design. So this is the demo I have already, but today this is the setup. Now I am going to show in 5-6 minutes one demo using Mqtt, which is basically following this whole TCP IP on the top, TCP IP on the top, and the bottom 802.15.4. Okay, so that demo I am going to show, which I have used basically for my class. Here my research student is going to show this demo. So there is a demo for 30 minutes, but I will run only few minutes. So this is the basic setup. Okay, let me share this first. Where is this? Okay. So now this is the demo. This is the demo for MQTT protocol, and in this protocol, first my student will explain this part, how this is done, and then the coding discussion part is there. I will skip that part. I will come to the live demo at the end. Let me run.
Finally, we will run through the code and also see the live demonstration. So we are going to have a demo using MQTT protocol. What will be the final objective of this demonstration is, as you can see here, very first thing, to send the sensor values to a cloud using the MQTT protocol. So this is the entire setup on my right hand side. That is this laser pointer you can see here. In the very first part, we have this MQTT broker. This is nothing but a Raspberry Pi, which is acting as an MQTT broker. The second thing is a small setup consisting of the Node MCU as well as the ultrasonic sensor, which is an MQTT client acting as a publisher in this case. These two are having data communication, but before that, we needed to connect them to a common access point. In this case, the Node MCU, using its Wi-Fi capabilities, is connected to this access point, while the MQTT broker, that is the Raspberry Pi, is connected with the help of this Ethernet. The second thing is, after these two are connected to the single access point, with the help of the access point, we are able to also access the internet cloud server, which is also an MQTT client acting as a subscriber in our case. The data communication is taking place between the internet cloud server as well as the MQTT broker, while the internet cloud server provides us, or in other words, the end user, a wired or wireless medium along with a user interface so that he or she can check what are the values that are being occurring. So, as you can read in brief points, the ultrasonic sensor reads the distance between itself and the object, and it sends the measured distance to the cloud server using the Iot protocol. And in this case, the cloud server is nothing but the thingspeak.com. So, what are the basic requirements?
Okay, I am coming to the demo part because now it is going to discuss the connection, how to form the connection, how to write the codes inside the node MCU, inside the RPI. Okay, so these are the codes basically. I'm going to the how to form the account there in ThinkSpeak. So everything has been discussed. Yeah, I'm coming to the live demo part here.
So, as you can see, this is the entire setup. First of all, we have the access point, that is nothing but the TP-Link router in our case. This access point is providing the router facility to every device that we can see here. So this is one of the Mqtt clients acting as the publisher because it has the onboard sensor, that is nothing but the ultrasonic sensor. Along with that, the connections are made with the ESP8266 client, that is nothing but the node MCU. These are working as publishers in this case, which are in general MQTT client. This is nothing but the MQTT broker, and this is running the server integration program, which will pass on the values it is receiving from this client, and then it will pass on these values to the ThinkSpeak cloud service. So as you can see that in the middle, for very first is nothing but the VCC connection. After that, we have the trigger connection. After that, we have the echo connection, and finally, we have the ground connection. What's happening is that I will show you. Once we start running the program, so now we are able to see the distance on the serial monitor. This same distance we will be able to see onto the MQTT broker. That is nothing but we are going to open the Raspberry Pi window so that we can see this program, which is nothing but the cloud.py. This is the program which has been which is the program written to send the MQTT broker values to the cloud. And once we start running it, we'll be able to see that it is connected with the result code 0, and this distance is then getting updated in this topic ESP8266/distance. The same distance will be also sent to the cloud broker. So I will show you the live demonstration of that part. So just for that, I will make this a bit larger so that you can see it clearly. So as I make my camera, you can see that. This is the object, and this is the ultrasonic sensor. So as I'll also show you the serial monitor. As I swap my object ahead, you can see the distance will be reduced from 22 to 17 centimeter. As I take it further close, it will once again decrease from 18 centimeter to 14 centimeter. And same values will be reflected onto the ThinkSpeak platform, which I have opened here. You can see the ultrasonic sensor. In this, we can see that the last entry was less than a minute ago, and the last value which we received was around 14. So that will also get updated very shortly. You can see the point has been updated. This alarm has been configured such that it will close up the red light once the value reaches the 100. So let me just flip over this device sensor so that it calculates the distance between itself and the ceiling, which is obviously more than 100 centimeters. So as soon as you can see that the device is getting very important. So now this time when I just flip it up, now as you can see that as soon as we hit the 101 centimeter, the red light has glowed in the background of the ceiling. The value also got updated as soon as and we receive the red light glowing. Once again, when the value is less than 100, which you will obviously be able to see on the serial monitor as well. So it is now 13 centimeter, and now if we see here, the light will stop glowing once the value gets updated here. Since it is once again an error from value that is 2367, that is showing, and now you can see that the light has gone diminished because after that we have received a 13 value.
Okay, so now I have stopped sharing. So now it is completed from my side. The presentation is completed now. So now if you have any query, any question, and then we can have these questions.
Thank you, sir. Thank you for this wonderful session. So we have a couple of questions in the Q&A section. So if you permit, we can read it out, sir.
Okay, Q&A. Yeah, I can see also. Nice.
Okay, sure.
Okay, so let me check a video monitoring and surveillance application. Can you explain clearly about the type of camera required and the position of camera, especially in a highway, to read the vehicle information accurately? Okay, so that is actually you have to design that. Okay, in which position, if we place the camera, then it will be able to capture. That is a computer vision part. Okay, that there are different algorithm also designed. Means if you capture the image tilted manner, or if you capture from the top, from the angular manner, or from the side, then how to get the information. Let us consider one information could be the vehicle registration number. How to extract this registration number? So there are different algorithms. According to that algorithm, we can finalize the position and the angle. Okay, so that we have to decide based on this algorithm. There are many algorithms related to that. What is Beccal core network? Beccal core network, as I mentioned, the traditional internetworking infrastructure. For example, the internet. That is the Beccal core network. Maybe cellular network also. The cellular network also we can consider as a Beccal core network. Beccal network means by which my data can reach from one location to the other location. These two locations are geographically far apart. Cloud is necessary for the implementation of IoT? No, not at all. Cloud is not necessary if you do not want to perform the huge data analytics application. Or if you have some sort of local server, some application running inside the server, then we don't need the cloud at all. So that's why at the beginning, the first part of my presentation, I tried to show that access technologies. For example, the IIT local network, LAN. If we want to run the local network inside the IIT Guwahati, we don't need the internet connectivity. We don't need the cloud. We can run here. That is why I have shown the enterprise access network. IoT can also be designed as an enterprise network, and we don't need the cloud. We can use the cloud if we want to get the features which are available in cloud. is IoT application can be made possible without using internet service? Yes, internet service is not at all required, because we need the network. We need to form the network. That is what I told already. IIT Guwahati network can perform everything without internet related service. If we do not have the internet, then also it can perform its local activity. Suppose IIT Guwahati has its own authentication server, own mail server, own database server. So I can access the information collected, means information placed in the server from my local client, from my system. I don't need the internet. Internet is required when I want to access the maybe Google server. I want to access. Maybe I want to access the Microsoft server. Then internet connectivity is required. Similar for IoT also. How to file the attendance for these days? Okay, this is something different. Attendance is already approved. Okay, that's all from the question, means those who raised this question. I hope I have explained them well. If you have any further question, you can ask. Otherwise, we will end the session.
Sir, we would request the participants, if you want to interact with the expert, you can raise your hands. So once you raise your hand, we will unmute you and you can speak into the session. So interested participants can raise their hands in order to interact with the expert. We will unmute you and you can interact in the session. Thank you. So there are some questions people have posted us privately, sir. If you
you just read out one by one.
Tools or simulators that can be used for STI SCH protocol.
Which protocol name you mentioned? I did not get. TISCH.
TISCH, yes, sir. 6 TISCH.
Yeah. So the tools could be any contiguous. Any contiguous can run, and the simulator, maybe the Kuja simulator. One Kuja simulator is running this, means this is open source simulator. Again, you can download, you can run. Another open source simulator is 6TISCH, dedicated for 6TISCH network protocol stack, 6TISCH simulator. So there are two simulator basically. You can, these are both are open source. You can download and you can run and you can use.
Sir, one more question from one of the participants, Dr. Muthu Subramaniam P. Sir. So he has posted privately.
Yes.
Sir, he wants to know when Node MCU has the Wi-Fi and can transmit the data directly to the ThinkSpeak using API key, what is the need for Raspberry Pi here? Any specific reason for using the Raspberry Pi?
Broker, to design the broker. I have tried to design. You can design the broker in cloud server also. Because I have used this Mqtt application. So Mqtt client means publisher, broker, and subscriber. So these three components are required. To show the publisher, I have used the Node MCU connected with ultrasonic sensor. And to show the broker, Mqtt broker, I have used the RPi. If you want to use this broker, if you want to run this broker in cloud server, then we don't need the RPi. We can directly connect with the internet and go to the broker.
Thank you, sir. So one more participant has raised a query privately, Ms. Santoshi Rudrakar ma'am. So she asked, in physical layer and data link layer, which protocols are mean in case of smart farming based IoT systems?
Smart. See, this is again based on your application. Physical layer and data link layer will not be decided separately. They are generally comes together, and there are different technologies. Smart farming system, yes, depending on the criteria. We have to decide that, okay, maybe the range, communication range I told, whether I want to run this application in a small range area or a bigger area. Then depending on this, I have to decide which technology I will use. Small area, Zigbee is okay. Larger area, Zigbee is not okay. Either I have to go the IoT version of the Wi-Fi, which is the Hello 802.11ah, or we have to go to the LoRa, which is LoRaWAN, or we can use the long distance low power network, another network, which is the sub-gigahertz cellular based. So depending on this requirement, we have to decide. There is no fixed answer that, okay, for smart farming, this is the only technology we have to use.
Thank you, sir. So next participant, Miss Kabrambam Singh ma'am asked that, sir, can I read the sensor data from Node MCU by the smartphone through Wi-Fi?
Yes, we can design the application, means we can deploy the application inside the smartphone, and then automatically this application will connect to the sensor Node MCU, which is connected with the sensor, because sensor does not have this communication capacity. Sensor is the ultrasonic sensor, which I have shown in the demo. It does not have this communication. So to provide this communication, I think at the beginning of my first session, I told that these objects should have few additional features. Among them, one of them is the communication capability. So this Node MCU has this communication capability, and it has the Wi-Fi communication, means this is inbuilt. Those who have manufactured, they have put this Wi-Fi. So that's why we can use this Wi-Fi. Otherwise, if the TSCH is available, just like as I have shown, maybe this is the Texas Instrument device. So this is the TI device. This is TSCH based. Now, this TSCH based sensor also we can, sensor node also we can use for communication, and smartphone, from this device smartphone I can directly connect. We have the application already designed by the TI. We can deploy this application in the smartphone, and we can access this device directly. We don't need anything else.
Thank you, sir. So next question from another participant, Mr. Manish Sharma, sir. So he is asking that, is it necessary to have broker to transmit the data to cloud?
If we use the MQTT, then necessary. If we use the COAP, not necessary, because inside the COAP there is no concept of broker. It is just like our HTTP, client server mechanism. Server is running inside the cloud, client is my device, or if I want to send the data, then server will be considered as the my device, my sensor device, and client will be considered the application which is running in the cloud. That cloud application will send me the request. Send me means my sensor device. It send the request to the sensor device that give me this value, temperature value. Then this sensor device will send the data to the server, to the cloud directly. So MQTT, this is the structure, this is the architecture. Publisher, broker, subscriber. Broker must be in between. For MQTT, without broker will not work. But for client server architecture, which is COAP, there is no device in between, only the client and the server.
Sir, a couple of questions from another participant is there, G. Krishnaveni ma'am. She has posted in the Q&A section. So she is asking whether ultra wideband UWB can be used in IoT, and also Y gig. Yeah.
Can you repeat, please?
So whether ultra wideband
Yeah.
UWB can be used in IoT, and also Y gig.
Yeah, means now See, the which band will be suitable, that I cannot decide, because according to that band, the physical layer physical layer protocols are designed. So those who have proposed this physical layer, they have decided, okay, this band can be used, that band can be used. For example, I told that 2.4 gigahertz can be used, for 868 megahertz of band can be used. So according to that, this is designed. Now there are research also going on to use different other bands also. This research is going on, and yes, if such kind of research becomes materialized, and any devices is manufactured according to that, then we can use the very high frequency band also.
Sir, with this, we come to an end to all the queries, sir. Thank you. Thank you, sir, for answering all the queries. So with this, we come to an end with this session 1 of day 3 of this online faculty development program. On behalf of the principal coordinator of this course, Professor Ratnajit Bhattacharya sir, I thank you, Dr. Manas, Professor Manas sir, for joining, for accepting our invitation and joining and coming into this platform and sharing your knowledge with us and all the participants. Thank you, sir.
Okay, thank you all.
Thank you, sir. So, sir, we request you to disconnect now.
Okay.
Sir, so dear participants, we will be starting the hands-on 2 today from 12:30 onwards. So it's already 12:10. So we request all the participants to have a 20 minutes break and come back by 12:30. And also we request not to disconnect your system. Please connect your system and then come back by 12:30. We also request all the participants to please go through the important announcement page, which is already been uploaded in the Google Drive link. So everyday announcement, we request all the participants to follow everyday announcement and work accordingly for smooth conduction of the program. Thank you. Thank you all. Good afternoon, Jitesh Kumar, sir. Can you hear me?
Good afternoon, ma'am.
Okay. Welcome, sir.
Thank you, ma'am.
So I'm making you the presenter in the program. So you are the presenter, sir. So you can share your screen and test once. Yeah, we can see your screen. Yes, sir. Your screen is visible. Now we will start by 12:30, sir.
Okay, okay.
Okay, thank you, sir.
So, good afternoon, everyone. So, now this is our hands-on number 2. And before hands-on number 2, we have to install some software. So, have you installed the Arduino Ide? And have you integrated the Node MCU? Have you installed the Arduino Ide? Please reply to the chat option. Have you installed the Arduino Ide? Am I audible?
Yes, sir. You're audible, sir.
So
Hello.
everyone, yes. Have you installed the Arduino Ide? Please acknowledge into the chat. So we see here how to install the Arduino Ide. So for this, you have to search on arduino.cc. This is the website, and this is www.arduino.cc. So like you have to write on the Google arduino.cc. So this is the website, and you have to open this website for installation of Arduino Ide. So this is the website. Please open this website, and in the website there is a software. Just click on the software. And from the first one, Windows, Win 7 and newer, you have to download the Arduino Ide from this link. So see here, you have to click on software, and there is Windows, Win 7 and newer. You have to click on this and click on the just download. And now you have to download this Arduino 1.8.19 Windows.exe. Similarly, for another operating system, imagine if you have Linux 32-bit, 64-bit, then you can download from here. And if you have Linux ARM 32-bit, Linux ARM 64-bit, then you can download from here. And if you have Mac OS, so this is the link. Here from the Mac OS, you can download. So now you will get the Arduino Ide. Now you have to install it. You have to install by next. You have to install this Arduino Ide. So this file is already shared. So have you installed the Arduino Ide? Please acknowledge. Participants, have you installed the Arduino Ide on your laptop? Only one reply out of 300 participants. Please acknowledge quickly. Have you installed the Arduino Ide on your laptop? Okay. So now this is the first step, installation of Arduino Ide. Now the second step, we have to program the node MCU by using Arduino Ide. So how to make capable a Arduino Ide to program node MCU? So for this, we have to do ESP8266 setup using Arduino Ide. So just click on the file in Arduino Ide, then click on the preferences. Just click on the file and click on the preferences. Everyone, we do this quickly. So now I am also doing with you. See here, just click on the file and click on the preferences. So here in the additional board manager, I am giving this link. So first, what to do, you have to paste this link. The link is shared in the chat. So you have to paste the link in additional board manager URL. The link is shared into the chat. So just copy that link. Don't open, please don't open that link. Just copy that link and paste it here and then click on OK. I am repeating again. Click on File, click on Preferences. Now, a link, you have to paste a link here. Which link? That link is shared into the chat option. So open this link. Copy that link and paste it here, additional board manager URL, then click on the OK. So you have to paste the link here. The link is shared already. Now you have to open the board manager. So how to open the board manager? You have to click on Tools in Arduino Ide, then click on Board, and in front of board there is a Arduino is showing. So go to here the board manager. See the red boxes is navigating you how to open. First click on Tools, then there is a board, and here is the board manager. Everyone, I am also doing with you just Tools, Board, and Board Manager. So now, when the board manager is open like this, you have to search. Everyone, please see here. You have to search ESP8266. You have to search for ESP8266, and there is a board will come by ESP8266 community. So you have to search here ESP8266. So this will come. Now select the version. Now select the updated version and install it. Select see here, you have to write ESP8266, select the version number, the updated is 3.0.2 and click on the install. So now it will take some time for installation. It will take some time, approx 2 to 3 minutes. Please do this process. Everyone, do quickly. So have you done this? Everyone, please acknowledge. Have you done this, everyone? So have you downloaded the Arduino? Have you integrated the ESP8266 with Arduino Ide? Is there any other doubt? I am repeating again, what is the process? So first you have to install the Arduino Ide. So how to install Arduino Ide? You go to the Arduino website, arduino.cc, and click on the software. Then you have to download the Arduino Ide according to your operating system. Now click on the file. Now Arduino Ide is installed. After installation is completed, now you have to open the Arduino Ide, click on the file and click on the preferences. Click on the file, then click on the preferences. Now here the additional board manager URL, you have to paste the link. So please, this type of links is already shared into the chat. So copy that link and paste it here. Add additional board manager URL. Then click on the OK button. Now after pressing the OK button, you have to go to the tool. And here is the board is showing Arduino Uno. Means by using Arduino Uno or by using Arduino Ide, you can program Arduino Uno. But right now we have to program Node MCU by using Arduino Ide. So just click on the board manager. This is the path tools, board and board manager. Here you have to search about ESP8266, and when it will come ESP8266 by ESP8266 community. Now you have to install this board into the Arduino Ide. So in the board manager, you can use different boards. So for ESP8266, you have to install this board manager package. After installation, it will show like that. It is successfully installed. So now tell me, have you installed paste the link again? Okay. The link is already pasted. You can check by scrolling down, scrolling up. Just give me 1 minute. So this is the link. Okay. So this is the link. So this is the now your Arduino Ide is now capable to program the Node MCU. So now this is the software from the software installation. So everyone, have you installed this? Have you installed Arduino Ide and also the integration of Node MCU? Have you done it or not? Have you done it? Everyone? Yes or no? Please acknowledge. Is there any confusion, any doubt, you can ask by writing into the chat. Everyone? So now, what is the experiment? What is the hands-on in our hands-on number 2? So see here, first before explaining the hands-on, we have to understand some basic electronic circuitry. There is some basic circuit also. So that is the voltage divider. So we have to understand about the voltage divider rule. First, we have to understand this voltage divider rule. So see here, imagine there is a voltage and this is the resistor and this is the second resistor and this is the ground. And this is the resistor R1, this is the resistor R2, and here we need voltage, V output, and here is DS, that is the battery positive is here, battery negative is here, this is R1 and R2. So now tell me what is the value of VO? What is the value of VO? Is at this point, what is the value of the voltage? This resistor is R1, this resistor is R2, this is battery positive VS, this is the ground. Now tell me what is the value of VO? Now tell me what is the value of VO? Yes. So the value of VO is VS multiplied by R2 divided by R1 plus R2. This is the voltage divider rule, we can say it. So V output is VS multiplied by R2 divided by R1 plus R2. So by KCL or KVL you can calculate this. So now we have to understand the case 1. What is the case 1? So in case 1, imagine R1 has big value. R1 resistor is a very high resistor value, high resistance value, which compared to R2. Imagine like R2 is 10 mega ohm, R2 is 100 ohm. So that time tell me what is the value of VO? What is the value of VO then? If R1 is a very big resistor. So if R1 is a very big resistor and R1 plus R2 is approximately R1 because R2 is very small resistor. So VO is approx, we calculate is approx to 0 volt. This is very less. If R1 is a very big resistor, so here V output is approx 0 volt. And if there is a case number 2, now if there is a case number 2, in case number 2, if R1 and R2 both are same resistor, same value resistor, R1 is equal to R2, then what is the value of V output? Then what is the value of V output? Yes, the value of V output is Vs by 2. Yes, so it is the half. Okay, so now there is case third here. If R2 has very big value, R2 is a very big resistor with compared to R1, then what is the value of VO? Then what is the value of VO? So it is approx VO is equal to VS. Means all voltage is available here. It is approx equal to VS. So all you are agree with this case 1, 2, 3. This is the voltage divider rule. So we will save it for our use. So this is the voltage divider rule. I am saving it because we have to use this concept. So I am saving it with voltage divider. So is it clear to everyone? These things? All you are agree with this? So VO is, if we calculate Vs into R2 divided by R1 plus R2. Case 1, if we consider if R1 is a very big resistor. So in the denominator there is a big value, so VO is approx 0 volt. And if R2 is a very big resistor with compared to R1, then all voltages appeared here. Then VO is approx equal to V. If R1 R2 both are equal, then mathematically you can calculate it is Vs by 2. Okay. Now see here everyone, there is another concept. Now everyone you know about the photoresistor. Everyone, do you know about the photoresistor, the LDR? Yes or no? So what is the property of LDR? What is the property of LDR? Let me put the light on the so in the LDR, if we use the LDR, if we put the light on the resistance LDR, the value of resistance decreases. When you put the resistor into darkness, the resistance value is increasing. So now in the voltage divider, see here, this is Vs. See here everyone. This is Vs and this is R1, the same point. This is the R2 and this is the ground. This is the R2. Now R1 is replaced by LDR. The point is R1 is replaced by LDR, light depending resistor. Okay, and we have to calculate the same VO here. Our question is the calculation of VO. Is it clear to everyone? Yes or no? We are replacing R1 with the LDR. Is it clear everyone? Yes or no? This is the LDR, light depending resistor. LDR. Is it clear or not, everyone? So now tell me one thing. So if the light intensity, Li, light intensity is increasing onto the LDR, we are increasing the light intensity. So this is actually the R1. We are connected, we use LDR at the place of R1. So when we put the light, it means R1 is decreasing. Yes or no? This arrow is showing increasing or decreasing. Up arrow means increasing, down arrow means decreasing. So when light intensity is increasing, we are putting light on LDR. So R1 is increasing or decreasing? R1 means LDR. Yes or no? R1 is increasing or decreasing? Yes, decreasing. Then tell me what is the value of VO then? Increasing or decreasing? If R1 is decreasing, so according to here, R1 is a small, R1 is decreasing. So tell me, VO is equal to then what is the value of VO? Increasing or decreasing? VO is increasing or decreasing? Just tell me increase. Yes, then VO will increase. Because whenever you put more light on LDR, the R1 becomes small. So this is the formula. I will write the formula also. VO is equal to Vs into R2 divided by R1 plus R2. Now tell me R1 is becoming small. Small and small when you put the light. So VO is now increasing. When R1 becomes small, VO is increasing. It's nearly about 2 Vs. Is it clear, everyone? Is it clear, everyone? Yes or no? Everyone, please take it. This is a very simple thing. Okay. Now, the second case, the light intensity we are decreasing, means we are putting darkness, we are putting this complete circuit into the darkness. Means there is no light, light intensity decreasing. Now tell me, R1 is decreasing or increasing? R1 is LDR, yes, R1 is increasing. If R1 is increasing, then tell me VO increasing or decreasing? See here, the R1 is increasing, R1 is greater than R2. Then tell me VO is increasing or decreasing? Yes, in this case, VO is decreasing. VO is decreasing, yes. So now everyone, please focus on these two things main. So in one case, and this is the second case. So when light, so see here, when light intensity is increasing, VO is increasing. When light intensity is decreasing, VO is decreasing. So it means when we put this circuit into the light, so here if we connect the LED, imagine with the series resistor, if we connect a LED, this is the LED, imagine. This is the resistor, normal resistor, 330 ohm or 220 ohm, 330 ohm. This is 330 R. Imagine. So when we put this circuit into the light, this LED will glow. When we put this circuit into the dark, the LED will go off. So now in light, this LED is glowing, and in darkness, the LED is not glowing. So now tell me, this is the light sensor or dark sensor? This is the light sensor or dark sensor? When we are taking this circuit into the light, LED is glowing. When you put this circuit into dark, LED is off. So main thing is when LED is glowing, LED is indicating the status. So this is actually the light sensor. LED is glowing into the light. So this is the light sensor by using simple technology, by simple to register and by using Ldr resistor. This is the light sensor. Is it clear to everyone? When LED is glowing, that is important. LED is glowing into the light. This LED, I am talking about this LED that is connected at pin number VO. Please don't get confused. If you have doubt, please ask. Is it clear now? Shweta ma'am, this is a light sensor. LED is glowing into the light. Is it clear? Everyone? It is clear to everyone, yes or no? Okay. So this is the light sensor. Okay. So we created a new sensor. We made a new sensor. That sensor is light sensor by using some of few electronics components. This is the light sensor. Okay. Now again, the question is changed. Now you will tell you everything. So same thing. This is the VS and this is the resistor R1. This is the resistor R2 and this is the ground. So now R2 is replaced by LDR, light depending resistor. Now R2 is replaced by LDR and this is the same R1, normal resistor. And same question, this is the VO. We have to calculate, this is the ground. Formula is same, VO is equal to Vs multiplied by R2 divided by R1 plus R2. This is very simple formula. And now, yes, sir, you got the answer. This is the dark sensor. Now same, everyone. Now in this case, tell me, if the light intensity is increasing, this one. So light intensity increasing, it means R2 is increasing or decreasing? R2 is decreasing. When you put the light, resistance will decrease. So if R2 becomes small, so V output becomes small. Yes. Then if you decrease the light intensity, so R2 will increase, so V output will increase. Means now if we found a relation, if light intensity is increasing, V output decrease. Light intensity decreasing means dark. It means this is the light. We are putting this into the dark. So V output is increasing. So in the darkness, if we connect here a resistor, a LED, so LED will glow into the dark. So this is called the dark sensor. So this is called the dark sensor. Now it is clear to everyone. I think you already, when I made this circuit, this LDR at the place of R2, so you confirm this is the dark sensor. I think you understood this, everyone. This is the dark sensor. Is there any other confusion? Please ask if you have any other confusion. It is clear to everyone? Okay. So now, everyone, we have to understand. So this is the, so in the maybe in the light sensor or dark sensor. Imagine this is our light sensor. Imagine. See here, everyone. This is our light sensor. Hello, am I audible? Hello.
Yes, sir, you're audible, sir.
Actually, I'm not getting the chat option here to see the chat.
Sir, you can go in the top of the screen, and in that you will get a panel. Over there, you can find out the chat option.
No, I'm not getting the panel on the top of my screen.
Okay, sir. Let me check. So you continue. I will be checking.
Okay. So imagine this is the light sensor. This is the light sensor we already discussed, everyone. So in the light sensor, you can also put here the variable resistor also. You can put here the variable resistor, or you can put here the fixed resistor also. Okay. So in some cases, people will use the value a resistor, but variable resistor. So they change the value with the rotating the knob of the resistor. So they fix the value at then case. Then we made changes according to. So they put the R2 is very low or high, and depending on the situation when they want to turn on the light, so the R2 may be in some cases a fixed resistor or variable resistor. Okay, so this thing please consider into your mind. Not people think R2 is that fixed resistor. Not every time it is not possible. Sometimes people will use the variable resistor also. By rotating the knob of the variable resistor, they fix the value, fixed value. Then they do this type of experiment. So now, what is our objective? So see here in the node MCU. See here in the node MCU, we have to do this experiment. So I will show you the diagram. See here. This is the circuit diagram of our experiment. So see here, the node MCU is here, and this node MCU, and this is the voltage divider. So voltage divider, there is a LDR, and this is the resistor. So now tell me, this is a light sensor or dark sensor? First tell me by seeing this diagram. This is the 3.3 volts. You can say battery positive. This is battery is negative. Black one is the negative. Now tell me, this is the light sensor or dark sensor? Please don't go to the position of. Please don't go to the position of LDR resistor. You are seeing. You are everyone seeing the LDR in. This is R. This one is R2. This one is R1. Please don't see like this. See who is the connector to battery positive. So this LDR is connected to battery positive, and this resistor, this is actually the R2. This is R1 is connected to battery positive. So see here in the light sensor. See here, the LDR is connected to battery positive, R2 is, so this is the light sensor. Is it clear to everyone? It is clear to everyone, this is the light sensor? Yes or no? Everyone, please tell me. Yes, so this is the light sensor. So from this point, what you are getting by this yellow line, now tell me what you are getting. What you are getting from this yellow line? Voltage? Yes or no? When you put the circuit into dark, when you put the circuit into the light, so you will get the different voltage here by this yellow line. Yes or no, everyone? So now Now understand everyone what is the meaning of this. So please see here what we are doing in this experiment. So this is R1, or you can say the LDR. This is the R2, and this is the ground. This is the R2. This is the R1, and this is the VS 3.3 volt or 5 volt, and this is the, okay, so we are getting the voltage from here. So in the node MCU, this is your node MCU. This is our node MCU. So we connect, this is the voltage, this is the analog quantity. This is analog quantity. We are getting the analog value, we can say that. This is the analog node, analog value we are getting, voltage. So we connect this analog value to a pin. So there is a pin in node MCU, that pin is A0. That pin is related to analog to digital converter. So we will convert voltage into digital value. We will convert voltage into digital. So in in node MCU, there is an analog to digital converter inside the microcontroller. This is the peripheral that is converting the voltage into digital value. That digital value, the range of that digital value between 0 to 1024, because this is the 10-bit ADC in the node MCU. The resolution is 10 bit. So we will get value between 0 to 1024. So this is actually the part of the analog to digital converter, converting voltage into digital value. Is it clear to everyone, this thing? First tell me, this thing is clear or not? Converting voltage into digital value, that digital value between the range 0 to 1024. This is cleared or not, everyone? Please acknowledge. Do you know the concept of analog to digital converter, everyone? The meaning of resolution, the meaning of step size, everyone? Is there any confusion regarding this? Is there any confusion? Okay. So now, so by using, now we will get different value, because the voltage range we will get between 0 to, the voltage range is 0 to 3.3 volt, and we will get digital value between 1, means 0 volt is saying 0 in digital, and 3.3 volt is saying 1024. So we are getting this value between, we will get any value. Imagine there is a 1.75, imagine. So we will get the answer 511 or 512, like this. Imagine we are getting this value. So these digital value, now everyone please see here, these digital value, now we are uploading the sensor value. See here, this digital value, now we are uploading into the IBM Bluemix. This is the IBM Bluemix. We are uploading this sensor value by using MQTT protocol. There is a protocol, IoT protocol MQTT. So we are uploading that value, and we will see that value onto the dashboard. So onto the dashboard in IBM Bluemix, we will able to see the live sensor data value onto the IBM cloud. This is our hands-on number 2. By using voltage divider, see here, by using voltage divider. So at the place of R1, there is a LDR, and at the place of R2, there is variable resistor. Right now I am using. There is a variable resistor. Right now I am using, and I am getting a voltage. That voltage converted into digital value by the node MCU. So node MCU have Wi-Fi capability. So node MCU can easily connect to the Wi-Fi. So by using Wi-Fi protocol, the node MCU is sending the digital value to IBM cloud. So we will get that digital value into the dashboard by using MQTT protocol, messaging queuing telemetry transport protocol. I think you heard this term already, the MQTT protocol. So this is the objective of our hands-on number 2, how to upload data using the IoT protocol. Is it clear or not, everyone? Is there any confusion? Please ask. Is there any confusion? Please ask. Everyone. Is there any confusion? I am asking again and again because I want to give you complete knowledge. Don't and why I am asking again, because the step first we understood the voltage divider, then we converted voltage into digital, then sending the digital value to the IBM cloud. So every stage is, I think, is clear. Data generation, then data upload by using Wi-Fi protocol and the MQTT. That is the application layer protocol of IoT protocol stack. We are sending the data. Is it clear to everyone? Is there any confusion? You can write your doubt into the chat quickly, please. If you have any doubt, please ask. How to use IBM Bluemix dashboard. That is our objective. Now I will explain how to use IBM Bluemix dashboard. That is our objective, ma'am. We will discuss in remaining 1 hour. How to create account on IBM Bluemix, then how to use the IBM. MQTT also you are going to cover. No, MQTT is not going to cover. MQTT, so how many you don't know about do you know about the MQTT or not? Please tell me. I will cover this topic in 10 minutes if you have if many people interested MQTT. Yes. MQTT is already discussed in last lecture. Yes. So what is your doubt? If you have any doubt which is related to MQTT, you can ask. Okay. So see here. So this is the, I am also saving this. This is IBM Bluemix. Okay. So you are able to understand this this thing by using Paint. I am using the Paint. You are able to understand or not? Okay. So in MQTT protocol, see here. Imagine this is, understand, this is my jewelry shop. Imagine I am explaining this by example. This is my jewelry shop. Imagine any other shop. Imagine a jewelry shop, and there are 2 persons. These are 2 persons. that is P1 and P2. P1 is telling me every day the price of the gold, and the P2 every day is telling me the price of silver. Okay, and P1 is telling, and this is my shop. Now there are two shopkeepers. These are shopkeepers or anyone. S1, S2, and imagine there is another shopkeeper, S3. So S1 is interested in gold and silver, both. S2 is interested in silver only, and S3 is interested into gold only. So they are telling me the price of the gold, P1 and P2 every day telling me the price of gold and silver at 10 a.m. Imagine. And then this is my shop, and I am telling you the price of gold and silver according to their interest. So S1 is interested in gold and silver both. So I am telling him the price of gold and silver every day. Similarly, S2 is interested only in silver. I am telling the price of silver every day. Similar, S3 is in gold. So this phenomena is going, and I am working as a broker. I am telling the price. I am getting the price from P1, P2 and telling the price to the S1, S2, S3. I am as a broker. So this thing is happening in business. Same thing is happening in MQTT. Yes, broker is, this is the data storage. So same thing is happening into the MQTT. So these P1, P2 in MQTT is called publisher. And these S1, S2 and S3, these are called subscribers. And this jewelry shop in MQTT is called broker. This is a software. So publishers are who are giving the data. Subscribers, they are getting the data. Who are getting the data. And the broker is here. So you can install broker on your laptop. You can install broker onto the IBM cloud. So right now IBM has their own broker. So the IBM is getting data from our NodeMCU. So our NodeMCU is acting as a publisher and it is sending data by using Mqtt protocol to the broker. And broker is onto the IBM cloud. Okay. So this P1, P2. So everyone, please see here. The gold and silver, these are called the topics. The gold and silver are called the topics. And imagine the gold price is actually 50,000 per 10 gram. Silver is 70,000 per kg. So this 50,000 and 70,000 is called payload. Is it clear to everyone? This is called a payload. This thing happening in MQTT. This is the so publisher and subscriber don't know each other. The publisher subscriber don't know the existence of each other also. P1 don't know if there is a S1, S2, S3. Similarly, S1 is don't know there is a P1, P2. Means there is no connection between P1 and S1. There is no connection between publisher and subscriber. Because middle item is broker. There is a broker. All the connection is through the broker. Is it clear or not? This is the analogy I use, jewelry shop analogy, to understand the MQTT. For if you are beginner to MQTT, you can understand like this. Is it clear or not, everyone? Now, is there any other confusion? Subscriber can also data storage. Yes, if have the capability, they can store the data. Subscriber can also store the data if they have capability. Depend who is the subscriber. Subscriber is any hardware they have connected to any other database. That is more important. Is it clear now? It is clear now? Yes or no? Everyone? Okay. So now our objective is how to upload data, how to use IBM Bluemix. Okay. So everyone, this is now IBM Cloud setup. Are you ready, everyone? How to set up the IBM Cloud? I am not getting again the chat option. The chat option is not visible at my end. I'm not able to see the.
You might have minimized the chat option because it is unable from the host part.
Okay. Now I'm getting. So
Yeah.
is there now is there any other doubt? That means subscriber can also be data storage like BigQuery, cloud storage. Yes, that's same. If subscriber has capability, then no issue, sir. Thank you, sir, Gulab sir. Any other doubt, please ask regarding to uh, this one MQTT. Hello, is there any doubt? Please ask. So if you are interested in understanding the MQTT, so I will suggest you. So please read these documentation. Just give me 1 minute. Everyone, please read this documentation. This is the Hive MQ. This company is the broker company. Means they made broker for us, and this is a paid one. Please remember, this is not a free broker service. This is the paid one. So let it open the website. It will taking some time. So there is a Hive MQ website. So see here in this website, when you go to developers, this is the documentation. Everyone. So please read these 11 blogs. So introduction to MQTT publishes one by one in sequential manner. First read about this, then till point number 11. So you have to consume at minimum 1 month. You need at least 1 month to understand this. If you are giving 2 to 3 hours a day, this is the in-depth sequential series of the MQTT documentation. So I am sending the link. You can use this for the. Please note down this. You have to read from first point. Introduction. What is the meaning of publish subscribe? What is the meaning of client broker connection? This thing. Is it clear, everyone? Yes or no? It is clear to everyone? Okay. Now everyone please do quickly the IBM cloud setup. Please everyone. So for this, there is a in the Google, please write IBM Bluemix. Please write IBM Bluemix. And the website is cloud.ibm.com, and open this website and log into IBM Cloud. And log into IBM Cloud. So just you have to create an account. Just click on create an account. And everyone please do quickly if you are interested in this. And please see here, just wait 1 minute, just wait. Right now I am using this hardware. This is our official hardware when we are doing experiments. So see here, this hardware right now I am using. This is our IoT development board by the IoT Academy, and this is our company's product. So this is the Node MCU. Are you able to see everyone? Yes or no? Are you able to see everyone? This one. So this is Node MCU, and this part. See here, there is a there is a resistor, and this is the LDR, and this section is resistor. In the place of fixed resistor, we use the variable resistor. You can put this, you can use this component on the breadboard also. So right now I am using this board. In this board, there are also different sensors. There is a ultrasonic sensor for range calculation. There is a air quality sensor. There is a gyroscope, MPU 60, and accelerometer. There is a OLED display, and there are DST11 for temperature, humidity, LED section. There are 3 LEDs are there, 2 buttons, push buttons. There are 2 this is the DIP dip switches are there, and this is the power section. So approximately there is DST11, LDR, air quality sensor, ultrasonic sensor, NPU 6050 sensor, and this is the OLED display also for the as a display section. And this is the node MCU section. This is the plug the node MCU and just use, and by using the wire we can use. So right now I am using this. Everyone, are you able to see? So this hardware right now I am using. So I am sending the link. You can see this, and you can also use the raw components. So this is our website uctrobotics.com, and here are a lot of boards are there. This is the one of the IoT development board, and there is also ESP32 LoRa development board. That is our new ESP32 with LoRa. This is the long range. So this is the board ESP32, and there is also another board for some industry. This is the Raspberry Pi learning kit. See here. This is the Raspberry. This is the Microbus. This is a breadboard, and this is the Raspberry Pi. This is all for the college lab setup. Actually, this is targeted for, we are making big college lab setup. If you any college interested in the lab setup, then we are. And also there are also kits on the market. You can see here lot of the kits. 14DR to RS485, IoT development board. This is the Arduino, LoRa Arduino. This is the Arduino with the LoRa communication. So see here, this is the Arduino, and same all the sensor, and we also use the LoRa communication. So you can use the LoRa communication with the Arduino. So this is the kit we are selling right now. So right now, one of the kit I am right now using, that is the IoT development board. This is our IoT development board. So it is, so right now I am using this. So how many participants do you have hardware, node MCU, and LDR and resistor? The list is already shared. Do you have hardware right now? Okay, so here the list has a hardware. Okay, Akhil Arora sir has hardware 2. Remaining participants, please write quickly. How many participants which have hardware right now? Please write quickly if you have right now. Please write. Then if you have Ankit Sharma sir also, Akhil Arora sir, Sayed Ali sir, 3 persons have their hardware. Remaining participants, please, if you have hardware, please write yes into the chat option if you have the complete hardware of today experiment. Okay. So please, if you have hardware, okay, there is another. Okay, sir. If you have hardware, please please sir, make connection. Please, I am showing you. Please make connection like this. Please see here. Please make connection like this. If you have hardware, please make connection like this. Quickly, sir. Please make connection. I am giving you 2 to 3 minutes. Please make connection. I will give you code. Don't worry. I will give you code. Please make the connection. Everyone do quickly. Okay. So have you made resistance value? You can use a 330 ohm, 330 ohm, 1 kilo ohm, no issue. Connection made. Please, everyone made this connection quickly. You have to connect at pin number A0. Please see here. This yellow line is connected to pin number A0 from this point. Please see here quick when the another resistor and LDR is here. So at the place of this resistor in my circuit, I am using the variable resistor. Okay. At the place of this resistor, I am using this one, the pin trim port. This is the variable resistor. Okay. So have you made the circuit? Have you made the circuit? Yes or no? Remaining participants, Ankit Sharma sir, Akhil Arora sir, please reply. Have you made the circuit? And also Pradeep Sharma sir, Y Rama Lakshman sir, have you made the circuit? Please acknowledge into the chat quickly, sir. I will. This is the circuit diagram. Please made this. That is the ground. Ground is connected to this resistor. This is the ground part. This is the 3.3 volt. And from this point, just use single wire and connect to A0. So have you made? Please reply quickly, Ankit Sharma sir, Akhil Arora sir. So now everyone see here. Do quickly. So now search for IBM Bluemix. Open the website ibmcloud.com and just click on create account. You have to create account on IBM Cloud and just write your email ID and password. Please write your email ID and password. Then click on the next. Please write your email ID and password and click on the next. And there is a verification code is sent by the IBM to your email ID. So you will get a verification code. So there is a 7-digit verification code into your mailbox. Just copy that code and paste it here. The 7-digit verification code. Then click on the next. Then click on the next. Now you have to fill the personal information, your first name, last name, country, and then click on the next. Same. So there are 3 processes actually. First, create account. For create account, for account information, you have to write your email ID, password. Normal password you can write. Then click on next. Second step is you have to verify the email. Third, the personal information. So verifying your email, and the third one is the personal information. Then click on the create account. Then you will get this page, proceed, acknowledgement page, proceed, and you will get this type of dashboard. IBM Cloud Dashboard. So are you getting the IBM Cloud Dashboard? I'm also doing with you. See here. IBM Blue Mix. Cloud.ibm.com. So I have already account on this. Yes, you have to fill the credit card detail. They will use, okay, they will ask for credit card. You have to fill the credit card detail. So this is the dash. So are you getting this type of dashboard? You have to fill credit card. They use only 2 rupees. So have you made the account? Have you made the account, everyone? Okay. Now see here, just click on the create resource, because which service you have to use on the IBM cloud, that is IoT. So just click on the create resource. See here, I am also doing with you. Just click on the create resource. And from the category, you have to find, this is the catalog, which service you are want to use. So right now we want to use the Internet of Things. So this is the Internet of Things services. So just click on the Internet of Things, and you have, there are a lot of services are there in the market. It is taking some time because to upload. So just click on the IBM Internet of Things. See here, everyone. On the services, the Internet of Things, then you will get the IoT platform by the IBM. So there are a lot of platforms available from different vendors, third-party vendors. So we have to use IoT platform from the IBM. So see here, this is one. See here, these are the different. So we have to click the Internet of Things developer by IBM. So this is the Internet of Things platform from the IBM. Are you getting, everyone? Okay, just give me 1 minute because we have already the plan. I have to delete. In your case, you will not get this. Just give me 1 minute. I have to delete my existing plan. So this is my existing plan. I have to delete. Okay. So now, everyone, when you got this, so we will choose the light plan. That is the free plan. In light plan, it include up to 500 registered devices and maximum of 200 MB of each data message. So, so we will use this light plan. That is the free plan by the. So just click on the light plan. Just click on this. I have read all the license agreement, and then click on the create. Just click on the create. So are you getting this web page? Let's get started with IBM Watson IoT platform. You can securely connect, control, and manage devices. And you can also quickly build your IoT application, analyze your data from the physical world. So this is the Internet of Things platform. This is called the IBM Watson. So for data upload, you have to click on the launch button. Just click on the launch button, and in the new tab, on a new tab, you will get IBM Watson IoT platform. On the new tab, you will get IBM Watson IoT platform. So are you getting, everyone, this type of IBM Watson IoT platform? Are you getting IBM Watson IoT platform? On a new tab, you will get. Are you getting? Yes or no? Everyone, please reply. Are you getting? So now here, you have to click on add device. You have to okay, ma'am, we will contact you. So we will contact you, ma'am. Just follow the steps, please, quickly, because we have less time. So I will share this email ID. This is my email ID. You can contact me, ma'am. So now everyone just click on the add device. Just click on the add device. Now here you have to select a device for the device that you are adding, and you have to give the unique ID to your device. That is, you have to write. So right now, please everyone, you have to write here the device type. So in my case, you can write like Node MCU. So please write different. Don't copy my device type, and my device ID is, I am writing here, my device ID is UCC 123. So that is the same I am. So please choose different one. So see here, click on add device. You have to write device type. It must be different for everyone. Please write and don't copy my device type and device ID. Then click on the next and leave it unfilled. These are the remaining things. You can modify the default service information and you can add more information. So just leave it unfilled. Just click on next. Now again, there is a key that is, we can say that for the security. So there is a authentication token. So you can write authentication token by your own auto generator. You can use by at your end. So see here, everyone. Click on next. Leave it unfilled. Click on next. So see here, this is the auto generator authentication token or self provider authentication token. So right now we are using auto generator authentication token. That is by default. Then click on the next. And this is the summary. This is my device. This is my device ID. Just click on the finish. Just click on the finish. Okay. So this is our organization ID. This is the device type. This is the device ID. So this type of thing you are also getting. Organization ID, device type. So please copy these things. You have to copy these details onto the notepad. We need these details when we upload the data. So right now I am copying into the code also, into code. Okay. So you have to copy all these 5 details. And this is device type and this is the same. And this is the authentication token. I have to update here. So please everyone, you have, and the 5th is the use token method. This is the same. So we can also update this one. We can also. So please copy that detail onto the notepad. So have you done this, everyone? Yes, we will share the program. Just give me 1 minute. Just give me, sir, we have to do more steps. So everyone, just you have to do this. So now open the Arduino IDE. Open the Arduino IDE. And click on the sketch, include library and manage library. Just click on the sketch, include library and manage library, and you have to install the PubSub client library. Please see here, you have to write PubSub client, publish subscribe, PubSub client into the search. So there is a library PubSub client by Ldr. Please remember who is the author. That is very important because we are using that person library by Ldr and version number is 2.8.0. So right now, so I am also doing with you. Just go to sketch, include library and manage library. And it will take some time to open the library manager. So just give me, it is taking some time. So now you have to write here sub client. You have to write here, it is getting sub client. Everyone, we do this. So this one, sub client by Nicolairi, this one, version 2.8.0. So please install this library. In my case, it is already installed. And also there is a Arduino JSON library. Please write into same Arduino JSON and please check the version. The version number should be 5.13.2. The version number is 5.13.2. Please check. Don't install the updated version. Don't install the updated version. The version number is 5.13.2. Please install this library. 5.13.2 Arduino JSON. Please don't install the updated one. Arduino JSON. And at my case, it is getting slow. This one, the Arduino JSON by Benoit Blanton and 5.13.2, it is already installed. So have you installed these two libraries? I am repeating again, the first is PubSub client, the second is Arduino JSON in Arduino Ide. Have you installed? Everyone? And now I am sending the code. Now I am sending the code, just give me 1 minute. Just give me 1 minute. Sending the code to you. So please check the Telegram group. The code is shared. Please check the Telegram group. The code is shared. So have you got the code? Have you got the code? Okay. Ma'am, please share into the Google Drive. Hello. Aditi ma'am, are you there?
Yes, yes.
The
Yes,
code is
sir.
shared to you, ma'am, in WhatsApp group, in WhatsApp. So please share this to the Google Drive.
Yeah, please give me 10 minutes. I am doing it.
Okay,
Thank you.
okay. And also the code is already shared. On chat, I am Akhil sir. I am not able to do. I am not able to chat. Not able to share here. Actually, I'm not able to do this. I have no functionality to. I only write the message. So the
So,
code is
in the
shared.
sir, dear participants, there is one announcement from our end. See, chat and Q&A section is used for text communication with the expert during the session. Okay. All the documentation sharing part is done through the Google Drive. So we request all the participants to please make a note of the link, which has already been shared to you all. So all the documents related to this course will be uploaded over there.
And in Telegram group, I will upload the code. Telegram group, we upload the code before the class actually. So in Telegram group, I already shared the code. Please check on the Telegram group. From there you can download. If you have please join the Telegram group. There is a code. So now in this code, please ma'am acknowledge when you upload the code in Google Drive. So in this code, this is the
Yeah, sure.
library. Please acknowledge. So this is a ESP8266 Wi-Fi dot and PubSub client Arduino JSON. So here in this code, when you will get the code, you have to write your SSID and password, your Wi-Fi name and password in accurate manner. Then same thing, the organization ID, the 5 details what you got here, what you stored, the 5 details. See here, where is the 5 details? This one. These 5 organization ID, device type, device ID, you have to write here. Organization ID, device type, device ID, and token. Fourth one is the token. And the fifth one is already written. Don't use token auth, the authentication method. So you have to fill the details which you copied from the IBM cloud. This is the IBM cloud credentials. Okay, you have to write into the code. And these are the server details. The server is, you can say, the broker detail, messaging.internetsync.com.ibm, and these are the IBM, and these are the topics, and these are topics level IoT2.evt/status, FMT JSON, IoT2 CMD LED FMT JSON. These are the MQTT topics. So we are making our Node MCU as a client, as a you can say MQTT client. That MQTT client act as a publisher. So this is the callback function. When broker will send data back to the subscriber. And this is the how to make Node MCU as a MQTT client. So this is the library. See here, there is a library, PubSub client library, and when the documentation of this library, you will find on the Google right here, PubSub client ESP8266. The code is uploaded in the Google Drive. Please check. So this is the documentation of PubSub client library. So this is the documentation of PubSub client library.
Hello. Hello.
Yes.
Yeah, Jiti sir, the code has been uploaded in the Google Drive.
Okay. Thank you, ma'am.
Thank you.
So please, everyone, you can download the code from the Google Drive. Please do it quickly. So this is the PubSub client library documentation. And so now have you got the code, everyone? In day 3 folder, the code has been uploaded. Okay. Now please in the code, please update these details. Just give me one. So you have to fill these details. Your SSID and password and your organization ID. That means you will go from the IBM cloud, device type, device ID. Please write in accurate ID, otherwise, and copy paste the token also. And this is the function. Subscribe to broker. In the word loop, we are publishing the data. So we are publishing the data on the topic is the status topic. So now everyone, please go to the tools. Check here is the node MCU. Please select the node MCU if you are not getting here. See here, this is the path. In your case, it is showing Arduino Uno like that. Please see here, everyone. Please select the node MCU. Go to board. Then it will show ESP8266 board, and this is the node MCU 1.0 ESP12E module. Please see the path. Tools, board, then ESP8266 board, and select the node MCU 1.0 ESP12E. So have you selected? Have you selected? So go to tools, board manager. This is the node MCU, and the port number, at which port number you connected. In my case, it is COM3. It is not necessary at your end. It is COM3. Maybe a COM10, 7. So if you are not getting this, if you are getting different COM number, then open the device manager. Then open the device manager and check here the port, the Silicon Lab CP210X at port number COM3. The same port you have to. So see here the port COM3 is here. Same COM number we have to. Now just press this button. This is the upload button. So now we are uploading the data. Now code is uploading. So now, so have you changed the credentials? And please upload the code. Yes, device manager. So just connect the board, please. If you have hardware or not, ma'am, do you have hardware? Megha Sharma, ma'am, do you have hardware? Then it is not possible to select the port number, ma'am. You have to connect the board. That time you will get the port number. Without hardware, how you get the port number? You need hardware for this. So now everyone please see here what to do. Just go to here in the browse the left menu. Just click on the security. See here, just go to here and click on the security and just click on the connection security. Just click on the connection security, and here is the security level TLS with authentication token. We have to change. So here is the TLS optional. Just select TLS optional, click on OK and save it. I am repeating again. See here, click on the security. So just edit the connection security. Change the security level to TLS optional. Then click on the OK. Then click on the save. Now click on the board. On the left side, left menu, click on the board. See here. And here is the cards are there. So there is a user overview card and risk and security. So click on the user overview card. Just click on the user overview card. Now just click on the line chart. Just click on the add new card. Click on add new card. So there is a card type: bar chart, donut chart, value gauge, semaphore, device property. So just click on the line chart and select the device ID and device type. So just add new card, line chart. So this is my device ID. Just select this, and in the below just click on the next. Now here just check the code is still compiling. So let it upload. Just wait. In my case, it is taking some time. So just I am waiting. Just it is compiling still. Otherwise data will not. Now it is uploading. In my case, the serium home port are not successfully connected. Just let me connect it again and upload it. So if you are uploaded successfully, the thing here, now click on connect new data set, and when you click on the event here, the status word is automatically showing. That is the data is coming on this topic. Property is ADC, the event name is status. Is automatically showing or not? Say the sir, it is showing or not? The status, word and ADC. It is showing or not? Please tell me. Okay. So now code is, see here, the code is uploaded successfully. Connect a new data set. So right now, yes sir, you have to click on new data set. So see here, the status word is automatically showing the property ADC. And you can write here the name. Name is your live sensor data. These were automatically showing the data is a number, and data is number and max value is 1024, and click on the next and just see this is the size. So see here data is coming, and click on the next, click on the submit. So see here in the line chart, see here data is coming at my end. Yes sir, I am repeating again sir. See here. See here. Click on three cards, user overview card, click on add new cards, click on line chart, select device ID and device type. Click on connect new dataset. Click on connect new dataset. And here is the event. When you click on event, the status word is automatically showing. If your code is successfully uploaded, you are successfully connected to internet also. The status word is automatically showing. Just select, and in the property, the ADC, this ADC word is automatically showing. The name, you can write anything. Select the type number and click on next, and data is showing. See here, the data is showing. Now again, please write the accurate Wi-Fi path. Okay, now here I am writing the gauge. We will show data onto the gauge. Connect new data set. Property ADC same. Select Ldr data. Number is 1024 and click on next. See here, the 111 is coming. You can change the number. This is like, you can change it like this. See here. See here. So now when I put the light, see here, now I am putting the light by mobile flash. See here, the voltage is more, voltage is increasing because R1 is increasing. Now I remove the light and put my hand over it. So there is a darkness. That's why, and this is the normal light is falling onto the LDR. That's why data is showing like that. So I will share you the pic of the hardware. Just give me 1 minute. I will share you the pic of the hardware also in the Telegram group. So this is the live sensor data you are uploading. Onto the cloud. Is it clear to everyone? Is there any doubt you can ask?
Dear participants, if you want to interact with the experts, we can unmute you also. You can simply raise your hand and we will try to unmute. Thanks.
So this is the process. By using this, you can upload the data. So the code is already shared. And how to read this code? Some library from PubSub client library, you need documentation. The documentation is on the page. I already shared. This is the PubSub client library. The link is already shared. No, this board is Megha Sharma ma'am, this board is not for LDR. This board is, in this board there are a lot of sensors are there. See here in this. Just give me 1 minute. So see here, ma'am, this in this board there are lot of sensors are there. Right now I connected only 2 wires. In here only 2 wires. So ground is connected to ground and there is a voltage only. That is connected to the circuit is already made. So we connect voltage converted to digital and that we are uploading. So in this board there are a lot of sensors are there. DST11 temperature, humidity, LDR. This is the air quality sensor, ultrasonic, OLED display, MPUs. So in our next experiment, the next hands-on number 3, tomorrow we will use this MPU 6050. This sensor, MPU 6050. For our tomorrow hands-on, please, Node MCU with MPU 6050. Please notice this everywhere. MPU 60. We will use this sensor with Node MCU for our tomorrow hands-on. Is it clear? Yes. So can I use for the same speed of the motor? Yes. Why not? You can use easily. You have to use the PWM feature of the Node MCU. Then you can upload the speed of the motor also. Yes, ma'am. You can do. Is there any other confusion? So, Sayyid sir, are you getting the data? Are you getting the data or not, sir? Okay, okay. Is there any other confusion? You can ask your doubt. Okay, okay. Okay, sir. Thank you, sir. So just change the data into the gauge format also, sir. See here, sir. Just again click on add new card, sir, and select the gauge and select same device. Then the remaining steps are same, sir. And you will get data. And when you put the light by mobile flash, digital date, so you will get the value approximately. See here, in my case, right now, if I am using in IBM Cloud, this is IBM Watson. See here. So now I am putting some light. So see here, sir, data is changing. See here, I am putting more light. See here. So this is the light sensor, sir, which we discussed. And when we remove, so this is the normal light. And now I put the hand over the LTR, so there is a darkness. So see here, the value is changing quickly, changing within milliseconds. So is it clear to everyone? Is there any other doubt? So have you enjoyed the hands-on session or not? Please tell me, all respected faculties. Are you enjoying the hands-on sessions and theory sessions as well? Are you enjoying? Are you learning something or not? Okay, okay. Thank you, sir. So is there? Okay, thank you, sir. So for tomorrow, I am telling the hardware. In the tomorrow session, we will use this same board with Node MCU and MPU 6050. This sensor, MPU 6050. Is it clear? Now you can ask your doubt. Aditi ma'am, you can unmute if anyone wants to ask any doubt. Hello. Is there any doubt? Aditi ma'am, are you there? Hello. You can. So, ma'am, you can use the integration of Node-RED. Megha Sharma ma'am, you can use the Node-RED. You can install the Node-RED onto the, there is a tool, the tool name is Node-RED. So by using Node-RED, you can give the feedback. Please note the name Node-RED. Yes, yes, Node-RED. Yes, ma'am. You can install Node-RED on IBM Cloud, then you can see this data on IBM Cloud. Then by using the Node-RED, you can do. Okay, is there any other confusion, any other doubt? Thank you, ma'am.
Also, yeah, dear participants, if you want to ask anything verbally, you can unmute yourself. Miss, we will unmute yourself. You need to simply raise your hands from your end. So Pradeep Sharma has raised his hand, so I'm unmuting him. Hello, Pradeep Sharma. Can you hear me? Hello, Pradeep Sharma. Hello. Yeah, Pradeep Sharma, are you there? So I guess he is not right there now. So I'm unmuting him. So Gopinath sir has also raised his hand. So I'm unmuting him. Hello. Yeah, Gopinath sir, can you hear me?
Yeah, yes, madam.
Yes, sir. You can ask your query now.
Hello, sir. Can
Good afternoon.
we get the live demo how to use the IoT development board, sir? When you're adjusting the light, we can see that data is.
This one, sir.
Yeah, this one, sir.
So,
So
sir,
how to adjust the light and how to give the input and all that.
okay, sir. So we are using this board. We are programming this board using the Arduino Ide, and we connected the ground to the ground and the data pin. Here are two pins, sir. One is the ground and second is the data. The data pin is connected to the A0 pin. So we are getting voltage from here, and we voltage giving to the ADC pin of the node MCU. So ADC is converting the digital analog value. The voltage is converting into digital. That digital value we are uploading to. So this is that board we are using. In this board, this is a node MCU. It has microcontroller and ESP8266, and there is a Wi-Fi chip. So we can communicate. We can connect this board with the Wi-Fi. So by using Wi-Fi protocol, we are sending data to the cloud using MQTT. That is nothing. We are connected via wires, sir. The connection, there are the pins. So we are using female to female wire for the connection. There are the pins are there.
Okay, sir. That can you show that in a live demo, sir?
Yes.
Because suppose we will buy that board means we have to learn how to use that one.
Yes,
and also how you are adjusting the lights, sir, LED light.
by sir, mobile flashlight. Mobile flashlight, sir, I am using.
Okay, sir. Okay.
So see here, sir. Just give me 1 minute. Now you sir able to see the hardware.
Yes, sir.
So see here, sir. These two wires are connected.
Okay.
These two wires are connected. One, the green wire is connected pin number A0, and the second pin is connected as a ground pin, sir.
Okay.
See here, sir. See here. There is a two pins here, and these two pins are, sir, from LDR, and we already made this hardware, sir. See here. There is the LDR, and this is the variable resistor. So this is the ground pin, black one is connected to ground, and this is the green pin. This the green pin, this wire. By using this green wire, we connected to A0 pin of the node MCU. In the node MCU, that they written A0 pin. I will show you the picture. Just give me 1 minute, sir. So this pin, sir, ADC0, this pin, we are connected the
Okay.
output at this pin, and ground is connected. So there are 4 ground in this. You can connect any ground. So that is in our
Okay.
hardware we are using. Is it clear, sir?
Yes, sir. Yes, sir. Can we get it? Right now, the board is available, sir.
Yes, sir. You can, if you wanna purchase this board, I will share the number. You can contact on this number. On
Okay.
WhatsApp, you can. So this is the number. You can, if you wanna purchase this board, you can purchase from here. You can contact on this number. Okay,
Okay.
sir.
Okay. Okay, sir.
Just another.
Okay, sir. Thank you. Thank you.
So there is only, sir, 15 millisecond, 20 millisecond latency. So this is the actually we are using, sir, MQTT, and it is binary protocol. The overhead is very small, and it is a binary protocol. Can I use the Arduino logo to identify non-commercial content? I don't know about this Arduino logo. Arduino logo to identify non-commercial. Yes, your Arduino is a open source. You can use the Arduino logo, no issue. Arduino is open source. All Arduino codes, all Arduino hardware specifications are open source on Arduino website. Okay. Is there any other confusion? Anyone who wanna ask out verbally?
So I guess all the queries of the participants have been already answered.
Yes, you can use the Arduino board without the Arduino software. You can use Tinkercad. On the Tinkercad simulator, sir, you can use Arduino board without Arduino software. Yeah. There is a Arduino Ide already there. You can use Arduino board on the Tinkercad. A lot of simulators are there, but IoT work you cannot do, because in IoT you need a internet connection via GSM, via Ethernet, via Wi-Fi. So you need internet connection. For IoT you need hardware. Node MCU, ESP32, Raspberry Pi, BeagleBone Black, these types of hardware you require. That's very easily, then you can connect that hardware very easily to the internet. That is main thing. That's why it is called IoT. In IoT, if there is no internet, how can you say that is a machine-to-machine communication? So for IoT work, you need hardware. There is no simulator for the hardware. Tinkercad do it? No, sir. In Tinkercad, there is no node MCU. No, ma'am. Shweta ma'am, there is no node MCU. You cannot use node MCU in Tinkercad. No, sir, there is no simulator for RPi. You need hardware, sir. How can we say? We have to run the operating system. You can use as a, you can use, then you need computer or laptop. You can use the Linux environment, but you need hardware. And this is a compulsory. Without hardware, it is not possible. Okay.
So one participant is there, Pavan Shukla sir. So I am unmuting him. He has raised his hand. Yeah, Pavan Shukla sir. Hello.
Yes, ma'am. Yes. Good afternoon, ma'am.
Yeah, we can hear you. Please ask your question.
Sir, I'm audible, ma'am.
Yeah, you're audible.
Okay. Good afternoon, sir.
Good afternoon.
Sir, my question is that suppose let's say example, suppose that we have a ECG sensor and we connect with the Arduino. Then when we take its output, then how this output connect with our mobile and real time this information sent to my doctor.
So, sir, you need the Arduino Wi-Fi chip.
Yes,
First
sir.
thing. Then you have to upload. So you have ECG data that is the graph format.
Yes, sir.
So for this, you need any graphical user interface. That is data will show into as a picture. Where
Yes,
you
sir.
have to, because you have to send a picture in PDF file, sir.
Yes, sir.
So that time you need, sir, some Raspberry Pi system.
Acha, not use Arduino there, sir?
No, sir, not possible.
Okay,
Arduino
sir.
not capable. You need GUI based hardware.
GUI based Arduino.
Yes,
So
sir.
Raspberry
GUI
Pi is better.
Raspberry Pi is better. But Raspberry Pi
Okay.
you can send the data.
Okay, sir. But sir, my question is
Then
that
you then you need the OpenCV system also. OpenCV.
open CV system,
Computer vision. Computer vision.
computer vision.
Yes. Sir. By
Okay,
using
sir.
computer vision, you can send the data.
Okay, sir. Thank you, sir. But sir, when we doing this project work, if we are facing some problem, then I want to contact with you. Sir, if you have any problem.
No issue, sir. You can contact me.
Sir, thank you, sir. Thank
There
you.
is a mail ID. You can mail me, sir.
Okay, sir. Thank you, sir.
So in Tinkercad, okay, in Tinkercad, sir, you don't have any Wi-Fi module yet. There is another Raspberry Pi and other board. Raspberry Pi is only the one that is the most used board. You can use BeagleBone. Otherwise, if you are not in, that are the SBC, single board computer, BeagleBone Raspberry Pi. Otherwise, you can use microcontroller based board, but there is no graphical user interface. The speed is very less. There is only microcontrollers. These are called the microcontroller based. Okay, I think there is no doubt. Is there any other doubt?
No, sir. Almost all the doubts are being cleared. Thank you, Jitesh, sir. On behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharya, sir, I thank you, sir, for connecting today and taking this wonderful session and making day 3 of this program so successful. Thank you, sir. Thank you for joining. So, dear participants, before we log off, we would like to make one announcement. So, dear participants, all of you are requested to please go through the important announcement page in the Google Drive and follow it for the smooth conduction of the program. So, everyday announcements are already being made. So, we request you to follow through those announcements and work accordingly. Second is the day 2 attendance will be updated today by the end of the day. And all the presentation materials will be uploaded in the Google Drive. It is already uploaded. Day 3 presentation are already uploaded. So you can find out all the presentation and material related to the course as per the day. Okay. So day 1 materials will be saved in day 1 folder, day 2 in the day 2 folder, and thus respectively. So thank you all the participants for joining this program today and making day 3 of this program so successful. So tomorrow also we will be joining at the same time. The session will start from 10 o'clock. The link will be active from 9:40 onwards. So we request you all to make a note of the attendee link and save it in your system because the link will be remaining same for all the sessions henceforth. Thank you all. Thank you for joining. We request all the participants to disconnect from your end. We will be disconnecting the meeting soon. Thank you all.